हम ये एक्सटेंशन लगा रहे हैं।
लगा दो, कोई दिक्कत नहीं है।
अरे पापा हम दिखेंगे गंदा दिखेंगे।
कोई बात नहीं, लगा दो बेटा।
ये तो हट
हाँ
आपका कनेक्ट हुआ?
हाँ।
Hello. Hello, sir. Am I audible?
Yes, sir, you are audible.
Shalini, can you hear me?
Yes, sir. I can hear you. Good evening,
You are
sir.
doing okay?
Yes, sir.
Hey, Javier.
Good evening, sir.
Good evening, sir.
Good morning. Here it is.
Acha, there it is morning.
Almost
Yes, sir.
6:30. In
Yes,
fact, I have
sir.
been on the screen since 6 o'clock.
जी जी कैसे हैं सर आप?
आप तो काफी भिन्न लग रही हैं दाढ़ी में।
सर अभी थोड़ा नवरात्रि में बढ़ा ली थी सर, चल रही है।
ठीक है। अब आपको नाई के पास नहीं जाना पड़ेगा इस समय। ये पैंडेमिक के चक्कर में थोड़ा संभल के ही रहिए भैया
जी।
और सब ठीक चल रहा है आपका?
जी जी सब सही है सर।
और रुड़की में सब भाई लोग कुशल हैं?
सब ठीक है। रुड़की में इतनी प्रॉब्लम है भी नहीं कोविड की, अभी थोड़ा सा गनीमत है सर।
अच्छा, नहीं चलो अच्छा है, गनीमत ही रहे भैया। यहाँ पे तो हमारे यहाँ भी जहाँ मैं रहता हूँ वहाँ पे तो दिक्कत नहीं है, लेकिन वैसे नजदीक में ह्यूस्टन में बहुत लोग इससे संक्रमित हो रहे हैं।
ये तो है सर। इंडिया में भी दिल्ली में दिवाली के बाद काफी केसेस बढ़ गए, दिल्ली में भी और जगह भी। यहाँ पे भी ऐसे तो प्रॉब्लम तो यहाँ पे भी काफी है।
हाँ नहीं, यहाँ पे बहुत बढ़ रहा है। करीब 2 लाख लोग रोजाना संक्रमित हो जाते हैं। तो इतनी तेजी से बढ़ रहा है और इसके बावजूद भी लोग सावधानी नहीं बरत रहे हैं। ये बड़ा समझ में नहीं आता कि लोग क्यों नहीं सावधानी बरतते हैं, और इसका और कोई इलाज नहीं है, केवल सावधानी बरतना है बस।
बिल्कुल सर, ये तो है।
मेरी तो यहाँ पे आप समझ लो कि कारावास, घर में कारावास हो गया है।
अच्छा सर, हाँ सही बात है, निकलना भी ऐसे में मुश्किल।
नहीं, हाँ कहीं निकलना ही नहीं है, ऊपर से आदेश आ गए हैं कि भाई आप निकलिए मत।
अच्छा सर।
हाँ तो
प्रॉब्लम तो है सर।
हाँ बहुत बहुत समस्या है, लेकिन अब क्या किया जाए। देखिए अब
सही बात है, इसी के साथ ही रहना है सर अब तो, जो प्रॉब्लम चल रही है
इसके साथ ही रहना है। सही कह रहे हो, और कोई उपाय नहीं है हमारे हाथ
सही
में
बात
तो
है
है
सर।
नहीं।
जी।
और वैसे ही NIH में सब भाई लोग कुशल हैं?
सब कुशल मंगल है सर, ठीक चल रहा है आपकी कृपा से।
हमारी जब उनको मुझे मेरी याद दिला देना और सबको मेरी नमस्ते कहना। कह देना हम याद कर रहे थे।
जी जी बिल्कुल बताऊंगा सर। आप तो बराबर, आपका आशीर्वाद रहता है NIH के सभी साइंटिस्ट के ऊपर सर। मिलते हैं
आप सब लोग बहुत कर्मठ हैं और बढ़िया काम कर रहे हैं, और हमको बहुत प्रसन्नता होती है जब हम देखते हैं आप लोगों के काम को, पढ़ते हैं तो। वैसे तो रुड़की तो एक हमारा परिवार की तरह है।
सही बात है सर।
तो हमको आप लोगों का अक्सर ख्याल रोजाना ही आता है। अक्सर क्या हम घर में अकेले हैं तो इसीलिए और ज्यादा ख्याल आता है।
बिल्कुल सर।
तो शालिनी कब शुरू होने वाला है भाई? अब ये तो समय तो हो गया बल्कि।
यस सर, टाइम हैज, आई जस्ट इंक्वायर फ्रॉम, मैं अभी पता करती हूँ सर रवि सर से।
तो घंटे भर से बैठे हुए हैं और ये हमको हमने कहा इस बीच हम थोड़ा काम कर लें, लेकिन ये स्क्रीन को हमें उधर आने ही नहीं देता है। देखते
मैडम मेरा फोन पिकअप कीजिए।
तो अब देरी क्या है? किसी का इंतजार कर रहे हैं? तो जयवीर, इसके चक्कर में फिर आपका दिल्ली तो आना जाना कम हो गया होगा कि अभी भी आना
करीब बंद ही है सर। जितनी भी मीटिंग्स हो रही हैं सब ऑनलाइन ही हो जाती हैं।
नहीं, और चलो अच्छा है वो आपको लोग मिनिस्ट्री में नहीं तो बुलाते रहते थे, ये अच्छा है कि
हाँ, हफ्ते में 2-3 राउंड कम से कम लगते थे सर।
हाँ तो नहीं, चलो अच्छा। फिर अब ये एक पद्धति बन जाएगी कि भाई वहीं से काम कर लीजिए। तो अच्छा
हाँ
रहेगा।
सही बात है, सही बात है। एक नया रास्ता भी खुला है कि ये मीटिंग आधा घंटे की 1 घंटे की होती है और उसके लिए पूरे दिन दिल्ली जाना और आना पूरा दिन निकल जाता है।
हाँ नहीं, और फिर
अच्छा।
उसमें सड़क पे जाना कार से फिर जोखिम भी रहता है ना।
बिल्कुल बिल्कुल सर।
हाँ, आमतौर पे ये घटनाएं होती रहती हैं तो डर लगता है वहां पे।
जी। कल भी सेक्रेटरी साहब के साथ एक मीटिंग है सुबह 10 बजे, वो भी ऑनलाइन ही है, तो वो भी सब ऑनलाइन ही कर रहा है वहां से जितना भी है।
अच्छा, नहीं चलो अच्छा है, बस ऑनलाइन ही। हमारे यहाँ भी सब चीजें ऑनलाइन होती हैं। खैर यहाँ तो वैसे भी उतना झमेला नहीं है,
जी
टेलीफोन से बात कर लो, उससे काम हो जाते हैं।
जी। और डॉक्टर रामाधार कैसे हो भैया? आपका म्यूट है रामाधार जी, आपका म्यूट म्यूट है, आपकी आवाज नहीं आ रही है रामाधार जी। म्यूट, हाँ अभी। और कैसे हो रामाधार?
हाँ बस बढ़िया है, सब कुछ अच्छा है। बस और सुनाए आप अपने।
बस चल रहा है ठीक।
आवाज अब आई।
रामदास,
हाँ, सर को हमारा पड़ा
रामदास,
सर बीबीसी।
नमस्ते भैया, कैसे हैं आप?
बस सर आशीर्वाद है आपका, अच्छा है सर। फाइव
बच्चे बच्चे सब कुशल हैं घर पे? आपकी
बच्चे
पत्नी?
हैं सर, बेटी भी अभी अच्छी है, बेटा भी।
अच्छा, और भोपाल में तो आपके यहाँ काफी बढ़ रहा है ये कोरोना।
हाँ सर, आज सर केस सर 300 प्लस हो रहे हैं पर डे, 300 प्लस।
हाँ तो
अच्छा।
भैया संभल के रहना आप, सावधानी से। तो
नहीं
घर
नहीं
से
सर,
ही काम
कोशिश
करते
करते
हो
हैं।
कि दफ्तर जाते हो?
जी सर, ऑफिस तो हम जा रहे हैं सेकंड में से रेगुलर।
अच्छा।
पूरे हो गए सेकंड में, आपके 6 महीने हो गए,
हाँ,
7 महीने
तो
हो गए।
तो
रेगुलर
क्या
कर रहे हैं।
रामाधार जो पहले पहले वेव आई थी उससे ज्यादा केसेस आ रहे हैं अभी या उससे कम
हाँ
ही है अभी?
भोपाल में मैक्सिमम पहले 150 200 थे, अभी 300 हो रहे हैं आफ्टर दिवाली, दिवाली के आसपास।
ओह माय गॉड, मतलब
हाँ,
पहले से भी ज्यादा
दिवाली से
केसेस
पहले से
बढ़
ज्यादा बढ़
गए।
गए सर।
अच्छा।
मतलब समटाइम 320 350 300 यही फिगर मतलब कर रहा है, रेंजिंग कर
हम्म।
रहा है।
कुछ नहीं भाई, अपने आप ही केयर करनी है अब तो।
ठीक है, अब केयर जितनी हो सकती की जा रही है, ऑफिस तो जाना ही पड़ रहा है।
वो तो
शालिनी
खैर है
ऑफिस का
ऑफिस।
इंतजार कर रहे हैं हम लोग। शालिनी,
बहुत टाइम लगा। और त्यागी साहब सब लोग ठीक है? बच्चे कहाँ आजकल?
हाँ,
आपको नहीं सुन पा रहे हैं, आप
बच्चे
म्यूट हैं।
बच्चे बेटा फ्रांस में है और बेटी तो वर्क फ्रॉम होम यहीं से चल रहा है।
वर्क फ्रॉम होम चल रहा है। हाँ बेटा बताया, तो बात हुई थी उस दिन, तो बता रहे थे
हाँ।
फ्रांस में। चलिए अच्छा है। हाँ बेटा मेरा भी यही वर्क फ्रॉम होम कर रहा है अभी, घर से ही।
अभी वही सॉल्यूशन है एक बस।
बेचारा।
पौने
और
7
नहीं
होने
सब
जा
लोग
रहे हैं, अब
ठीक हैं?
किसका इंतजार है, ये
जैसा हो रहा
बड़ा
है, सब लोग
चक्कर।
ठीक है?
हाँ सब बढ़िया।
अच्छा ठीक। क्या प्रॉब्लम हो रही है?
और डॉक्टर शालिनी, ये काफी डिले हो जाएगा प्रोग्राम, वी आर ऑलरेडी लेट, और अभी इतने लोगों का होगा, थोड़ा जल्दी शुरू करवाएं अगर हो सके तो।
यस सर, बिल्कुल सर। रवि सर, shall I start?
अब मतलब देरी किसकी है, क्यों लोग
और हम दे आर वेटिंग।
अब जो देर में आए उनको छोड़ दीजिए, बाद में कर लेना।
हाँ सही है।
जी सर।
हाँ, ये बड़ा चक्कर है यहाँ पे।
अभी कितने कितने लोग ज्वाइन कर लिए हैं मैडम?
ये करीब 372 कह रहे हैं।
373
373।
370।
373 join सर।
बहुत है। अगर अमन
देखिए,
जो
अब 3 तो छोड़ के चले गए,
अगर वो आगे हैं तो
370
आई
रह
थिंक
गए।
वी कैन स्टार्ट।
यस
370, हाँ 3 छोड़
यस
भी
सर।
दिए, जा भी रहे से छोड़ के लोग।
हाँ, 3 लोग छोड़ के चले गए, 2 और आ गए, 3, अब 370 रह गए हैं।
यस सर।
फिर और लोग
गुड
आ भी
इवनिंग
रहे हैं।
everybody. Myself Dr. Shalini Yadav, working as a head and professor in Center of Excellence in Water and Environment in Rabindranath Tagore University, and also as a secretary of International Association of Water, Environment, Energy and Society. I welcome you all on this day of the international conference, which is jointly been organized by AMPRI, NIH, Valmi, RNTU, and CBRU. I invite Dr. Yadav, who is the Vice President of IAWEES. He has completed, I would just like to give an introduction of him. He has completed his doctorate from IIT Bombay, and then he contributed his services in the Council of Scientific and Industrial Research as a scientist. He was a founder member of one of the labs of CSIR and also founder vice chancellor of ISECT University, Hazaribagh. He is also a vice president of IAWEES. I invite Dr. Yadav sir to please welcome our president, IAWEES, Professor VP Singh sir. Namaskar sir, a very warm welcome to you.
Voice is not.
सर आप म्यूट हैं, यू आर म्यूट सर।
सर यू आर सर आप म्यूट है, अनम्यूट कीजिए सर।
अनम्यूट करिए
सर, आप अनम्यूट करिए सर, यादव सर। हाँ ठीक है, ओके।
Good evening to all, sir. I welcome to this important international workshop on application of water, application of remote sensing and GIS for water, environment, energy and society. This international workshop is organized jointly by the IWEES and IHE Netherlands in association with Rabindranath Tagore University, National Institute of Hydrology, CSIR AMPRI, National Cap University, Dr. C.V. Raman University, and Water and Land Management Institute, Government of Madhya Pradesh. It is one of the very prestigious workshops for the benefits of the researchers, for the benefits of the decision makers, for the benefits of the planner, towards the management of natural resources, and for the benefit of the society. I think with the participation of expert persons invited from all over the world shall be extremely beneficial to all, and I'm sure that this workshop will definitely give some recommendations that can be accepted by the, especially by the government of Madhya Pradesh, I can say, and we shall send this recommendation also to the government of India for consideration. So thank you once again for joining us and accepting my invitation at a very short time. Thank you so nice of you.
मैडम अनम्यूट कीजिए आपको।
Now I would like to welcome Professor VP Singh sir, who is a University Distinguished Professor, Regents Professor, and Caroline and William Endler Distinguished Chair in Water Engineering at Texas A&M University, USA. He is a registered professional and a registered professional hydrologist and an honorary diplomat of ASCE AAWRE. He is a distinguished member of ASCE, a distinguished fellow of AGGS, and an honorary member of AWRA and a fellow of many more societies. He has published extensively in the area of hydrology, irrigation engineering, hydraulics, groundwater, water quality, and water resources. He has received more than 100 national and the international awards, including 3 honorary doctorates. He has served as the president of the American Institute of Hydrology, chair of Watershed Council of American Society of Civil Engineers, and president of American Academy of Water Resources Engineering, as a president of International Association for Water, Environment, Energy, and Society. Many more credentials goes to his work, but I feel that to continue his credentials, words may be more and time may be less. So now I would like to invite Professor Vijay Pratap Singh sir to please welcome our honorary guests and the participants and the delegates.
Thank you very much, Dr. Salini Yadav. Can all of you hear me?
Yes, sir. Yes,
okay.
sir.
Yes, sir. Everybody is muted and everybody is listening you. Okay.
Okay. Thank you so very much. It is just before 7 o'clock in the morning in the United States, particularly at the place where I'm living. So Honorable Om Prakash Sakleshaji, Minister of Science and Technology, Government of India, Professor V.K. Verma, Chancellor C.V. Raman University, Bilaspur, Professor Santosh Chaubey, Chancellor Rabindranath Tagore University, Bhopal, Professor R.P. Dubey, Vice Chancellor C.V. Raman University, Bilaspur, Professor H.B. Raghavendra, Vice Chancellor North Cape University, Gurgaon, Professor V.P. Petia, Vice Chancellor Rabindranath Tagore University, Bhopal, Professor Gerald Augusto Corzo Perez, IHE Delft, the Netherlands, Dr. J.V. Tyagi, Director, National Institute of Hydrology, Roorkee, Professor A.K. Srivastav, Director, CSIR, Advanced Materials Processes Research Institute, Bhopal, Srimati Rashmi Shukla, Director, Land and Water Management Institute, workshop organizers, workshop conveners, including Dr. Shalini Yadav, Dr. R.K. Jaiswal, Dr. Jaiprakash Shukla, Professor Vivek Bhatt, Dr. R.K. Singh, and Dr. Manish Upadhyay, distinguished keynote speakers, participants, and guests. It's a distinct honor and privilege to extend to all of you a very warm welcome in behalf of the International Association for Water, Environment, Energy, and Society. First, I hope all of you, your family members, relatives, and friends are keeping safe and healthy, and pray that you all stay that way. Second, a word about the International Association for Water, Environment, Energy, and Society, in short, IAVs. IAVs was founded for promoting a dialogue between academia, policymakers, and industry working in the areas of water resources, environment, energy, and society through lectures, seminars, workshops, conferences, and forming teams for collaborative research. This dialogue will help further interdisciplinary collaboration and conversation and contribute to sustainable integrated development and addressing the grand challenges of the 21st century. More importantly, it will challenge people working in their silos and to think outside of the box, because water, environment, and energy have many dimensions: scientific, engineering, medical, social, economic, political, legal, and cultural. It is therefore vital that technical and non-technical professionals work together for societal welfare and help shape policy making for the larger good of the people. This is deemed to be the only way to meet the grand challenges of this century, some of which are water scarcity, food scarcity, energy security, health security, environmental security, mitigation of climate change, and development of future leaders who will become the guardians of our civilization. IAVs fits right there in meeting these challenges. Meeting these grand challenges in a rational and scientific manner requires volumes of empirical data which need to be collected, archived, shared, and analyzed. In this vein, this international workshop aims to introduce applications of remote sensing and geographical information systems for water, environment, land, and society is very timely. For remote sensing is a very powerful tool for monitoring spatially as well as temporally data for large areas. In geographical information system, GIS in short, is a very powerful tool for analyzing the data. So providing background to principles of remote sensing, the workshop will deal with spatial and temporal analyses for real-world applications, geoprocessing and modeling techniques, exploratory geostatistical analysis, and spatial data analysis for programming and customization and automation in GIS. The workshop conveners deserve a special applause for organizing this meeting, especially more so in this very precarious time when the world is struggling to cope with the COVID-19 pandemic. Their dedication, their commitment to advance the cause of social welfare through professional development are deeply appreciated. Let me wish all the participants very productive and fruitful 3 days. Thank you.
Thank you, sir, for enlightening the different areas in the different topics in the area of environment and water resources, GIS and remote sensing. Now I would like to invite Dr. Ravi Prakash Dubey, who is working as a Vice Chancellor in C.V. Raman University, Raipur. Under his leadership, the university has gained a lot of goodwill and prestigious awards. I invite you, sir, to say a few words on this workshop. Dr. R.P. Dubey, sir.
Ji, thank you. Good evening to all. It is a matter of great pleasure for me to be a part of this prestigious international workshop on application of remote sensing and GIS for water, environment, land, and society, which is organized by International Association for Water, Environment, Energy, and Society, and association with RNTU, NIH, CSIR, EMPRI, and WILMI, NCU, and CVRU. I welcome to all respected dignitaries, keynote speakers, and participants. As you all know very well, in the present circumstances, when the whole world suffering from pandemic 2019, the need of this type of workshop is very essential to use the tools to protect the environment and create awareness to the society. These tools, GIS and remote sensing, are not only used in natural resources, but also used in any disciplines like management, planning, etc. So in this occasion, I would like to say that the messages of environmental conservation contained in the Vedic and Puranic literatures are all based on Hindu religious philosophy. It has always been an environmentally sensitive philosophy. Nature or earth has never been considered a hostile element to be conquered or dominated. In fact, man is forbidden from exploiting nature. He is taught to live in harmony with nature and recognize that divinity prevails in all elements, including plants and animals. I think one note from Bhagavad Gita, which advises us to not to try to change the environment. Important it improve it or wrestle with it. So if it seems hostile at times, tolerate it. So I think we all are aware from this 3 days international workshop. In these words, I conclude, and I also congratulate to all speakers and participants, and wish to all success of the workshop. Good luck. Thank you very much.
Thank you, sir, for your priceless words. Now I would like to invite Professor H.P. Raghavendra. He has completed his doctorate from Indian Institute of Science, Bangalore, and then and has availed many government scholarships. He was also selected for the fellowship by the University of Singapore. He is a founding director, School of Technology, Pandit Deen Dayal Petroleum University, Gujarat, Gandhinagar, Gujarat. And then he was as a Director General of the School of Technology, Pandit Deen Dayal Petroleum University. He has 30 plus years experience in teaching and research and has contributed many important research papers in the national and the international journals. Presently, he is working as a Vice Chancellor in the North Cape University. I invite you, sir, to say a few words on this occasion.
Dr. Raghavendra is not participating because of some family problem.
Okay.
Dr. Raghavendra is not available due to some family problem.
Okay, sir. Now, I would like to invite Dr. Petia, Dr. Prakash Petia, who is presently working as a Vice Chancellor in Ravindranath Tagore University. He has an experience of both corporate and education sector. He has rendered his services and contributed in the area of environment during his tenure as a director in the Indian Institute of Forest Management. He had also worked as a managing director in the Sanchi Milk, which is a brand product in Madhya Pradesh, Bhopal, and campus director of the Doon Business School. He is also contributing his services as a visiting faculty for Asian Institute of Technology, Bangkok, for the Management Development Program. I invite you, sir, to say a few words for this workshop. Dr. Petia, sir.
Okay, thank you very much, madam. Actually, I feel privileged to be a part of this international workshop on very important subject, that is application of remote sensing and GIS, particularly with reference to the water, environment, land, and society. So it's a mix of both technical things as well as the social things where we are going to use it. So I am also thankful to the number of experts who are associated to first conceive the idea of organizing these workshops and then giving a practical shape to this workshop, which includes the Sri Om Prakash Ji Saklecha, who is the Honorable Minister for Science and Technology and MSME Government of Madhya Pradesh. Then we have Professor Vijay P. Singh, who is from Texas University, and he is also a president of the organizing this unit, which is IVIS. Then Dr. R.N. Yadav sir, who is the vice president of IVIS. These are the persons who are involved or behind the scene for organizing this. Then we have the number of other peoples, like I am also this Srimati Urmila Suklaji, IAS director from Valmi. We have Professor Vijay Kant Vermaji, Chancellor CVRU, and Professor I.V. Tyagi sir, director from NIH, Government of India. So Dr. Avinash Kumarji Srivastav, director MPD, Government of Madhya Pradesh. So Government of India. And we have number of other people who are behind the screen for organizing this workshop. So I am welcome all of you and all the participants. In fact, I'm just looking this workshop as a very useful, particularly I'm not going to the talking about the technical aspects, whether we talk about the active sensor or the passive sensor and how we are going to get involved into it. But I look from society's point of view, the use of this, both the remote sensing and GIS put together, whether how we are using for weather, how we are using for forestry, how we are using for agriculture, how we are using for biodiversity. So this has really changed the life technically as well as socially. But I see from the distance there are certain problems, and which is basically one of the major problem which I make out from the number of readings, that there is a lack of financial support because of the misleading priorities from the government and other financial agencies. So the kind of support which this GIS and the remote sensing sector should have got, there have lack of resources, required resources. Then also, I do not know, but from the readings I gather, there is some kind of lack of coordination between the remote sensing and maybe the GIS community. I am from this looking from the outside, it may not necessarily be a truth, but from the readings, from the literature I get, this is not as close as should have been possible and complementary to each other as such. Another thing which I have gone through the literature and got, there is a lack of manpower, and more than that lack of manpower, there is also a what you call misplacement of the expertise. Means the right expertise at the right place is also need to be identified and to be do it in case if we would like to get the complete returns from the this GIS and the remote sensing. Secondly, over the years, I think when we started with the social work, but later on there is a little bit inclination of the remote sensing as well as GIS on the business driven models. So we started for the defense of the country purposes. Later on, we have gone for the society, and now we are moving for the business. So that is little bit worrying where we have to end it. But this workshop certainly is very timely workshop, and I hope we will come to the track, and this both remote sensing and GIS work together hand in hand for the benefit of the society. I wish my good wishes to all the personals who are involved in organizing this workshop, as well as who are going to present their technical papers, discussions, social papers, etc. And the outcome and the recommendations of the workshop will certainly not only make us more technically viable, but also socially viable, and the use will be for the benefit of the mankind. So wish you all best luck. Thank you very much. Thanks a lot.
Thank you, sir, for enlightening the latest scenario in the area of remote sensing and GIS applications. Now I would like to invite Dr. Gerard Corzo, who is a hydroinformatics researcher with a strong background in computer sciences. He holds a PhD from Delft University of Technology and has joined UNESCO IHE and have been teaching, researching, and coordinating activities for the water science and engineering program. His research core is the use of machine learning techniques to simulate or predict hydrological extremes. His work has evolved from hydrological spatio-temporal methods to pattern recognition and tracking of events. He has also published a spatio-temporal analysis of extreme hydrological events book and is the winner of the Tiscon Award for the best research paper in the International Association of Hydrological Sciences. Currently, he is working on the big data applications in the water resources and is a senior researcher chair, Department of Integrated Water Systems and Governance, IHE Delft Institute, Netherlands. Welcome, Dr. Corzo. I invite you to please say a few words on the international workshop on remote sensing and GIS applications.
Yep. Thank you very much, Dr. Yadav. Thank you everyone for being here. I think this is an honor to participate of this activity and also to represent IHE. Delft in the Netherlands. As many of you may know, the institute, we are highly focused on water resources and the impact in the water in the world, and on how nowadays the sustainable development goals that are associated with water can be achieved. So I prepared just 3 slides, and maybe just to I don't know if you can see my screen right now, only to say thank you for this presentation, but also to mention a bit more about the Institute and why we are here in this GIS and remote sensing. Mainly hydroinformatics, and I don't know how many of you have heard about it and how it has developed around the world. IH Institute for Water Education, where you can see here the building. This is Delft in the Netherlands, and it's started more than 50 years ago to try to help or train people around the world in water resources and to avoid the consequence of extreme events. Nowadays, well, with the idea of the high technology, well, we have developed in many areas. We have developed different Master of Science and PhD programs in the areas of needs. IHE is part of United Nations water family and is the main institute, I would say, focused on water. And what we aim as is to give impact, and this what you are seeing in the screen is the more than 23,000 alumni around the world. We have also shared for this event and try to bring as much people to know about the remote sensing and the things that you all as presenters and you all as experts in the area of remote sensing have to share and to let us know what are your experience. But also we will also try to make a couple of presentations. So I will also go a bit into machine learning, extreme events, and what Professor Singh mentioned, space and time. And we are going deeply more into this interconnection between the dynamics of the events and how through advanced analysis we could identify patterns that will help this sustainability. So with this, I would say thank you, and for now, let you with Dr. Jadav with the rest of the presentation. Thank you. You are in mute. Sorry, we cannot hear you, Dr. Jadav.
Thank you, Corzo sir, Dr. Corzo. I think some of the participants has raised questions regarding certain for the presentation which you had given, but I feel that since it is the inaugural session, we can raise the questions later on. Now, I would like to welcome Dr. Avinash Kumar Srivastava. He has completed his, I brief introduction for him. He has completed his doctorate from Indian Institute of Science, Bangalore, and contributed significantly in the field of processing, characterization, properties, and applications of metals, alloys, composites, and nanostructures. He has contributed in various projects in the areas of advanced materials. He has also published more than 250 research articles in the different reputed journals and delivered invited talks in India and abroad. Many more credentials contribute to his success story, and presently he is working as a director, Advanced Materials and Process Research Institute, CSIR, Government of India. I invite Dr. Avinash Kumar Srivastava, sir.
Good afternoon to all of you, very distinguished gathering here. I am really thankful for getting chance to be part of this inaugural program on this very important occasion of the inaugural function of International Workshop on applications of remote sensing and GIS. Applications of remote sensing and GIS is very important field of various sectors like civil engineering, agriculture, disaster management, natural resource management, water resources, marine resources, and so on.
And water is one of the most important natural resources and physiological necessity for mankind. Use and development of water resources in a sustainable and scientific manner is very important in the modern age due to the regular increase in water crisis. Just for beginners, as we know, remote sensing first emerged in the 1950s and refers to the science and art of obtaining information about an object, area, or phenomenon through the analysis of data acquired by a device that is not in contact with the object, area, or phenomenon under investigation. Now, the remote sensing and GIS, that is Geographic Information System technologies, are being practiced for water resources development and management since the launch of first Landsat satellite on 23rd July 1972 by NASA. Remote sensing techniques have been widely used in sustainable management of water resources such as rainfall runoff modeling, hydrological modeling, irrigation management, flood forecasting, drought monitoring, water harvesting, and watershed planning and management. Remote sensing coupled with GIS is a powerful tool, and that's why we are here all together. For the evaluation and management of water resources. In short, my own institute, CSIR Advanced Materials and Process Research Institute, CSIR MP Bhopal, is one of the constituent laboratories institutes of Council of Scientific and Industrial Research, that is CSIR, DSIR, Ministry of Science and Technology, Government of India. The CSIR MP is contributing a lot by pursuing research in the area of lightweight materials, smart and functional materials, nanostructured materials, radiation shielding and cement-free concrete materials, waste to value-added materials, and having a full-fledged department on rural technology and water resource management, where we do have excellent expertise on remote sensing too. This department has mandate to carry out integrated water resources management. Main capabilities of the center exist in resource modeling by application of the remote sensing and GIS techniques. The Water Resources Management and Rural Technology Group of CSIR MP Bhopal has executed many R&D and applied projects since its inception in the year 1990, although the lab started in the year 1981. The group has mandate to carry out integrated water resources research and management supported by field studies and surveys. It has vision, scientific and industrial R&D that maximizes the economic, environmental, and societal benefits for the people of the country through watershed and waterland development, rainwater harvesting, water resource management, remote sensing, and GIS applications, rural employment, economic growth of tribal community. The group is working on the major areas of remote sensing and GIS techniques like watershed management, watershed remote resources, management development, hydrological modeling, land surface temperature modeling, groundwater contamination, and so on. There are various activities going on in this institute in this area. The conference is going to be very useful for academia, scientists, industry persons, and a large sector of common man directly and indirectly involved. With this brief note, on behalf of CSIR AMPRI and also on my personal behalf, I wish this very important conference a great success with various fruitful output and outcome. Thank you. Dhanyavad. Jai Hind.
Thank you, sir, for enlightening the specific areas of the Advanced Materials Research Institute and highlighting its contribution towards the society. Now, I would like to invite Dr. J.B. Tyagi, sir, from NIH Roorkee. I would like to give a brief introduction of him. He has completed his doctorate from IIT Roorkee and then contributed his services as a environmental hydrology division and currently working as a director, National Institute of Hydrology, Roorkee, Government of India. I invite you, sir.
Thank you, Dr. Shalini, and good evening to all. It's a matter of great pleasure that NIH is a part of this prestigious workshop, and on behalf of National Institute of Hydrology and on my own behalf, I extend my warm welcome to all the dignitaries, eminent speakers, guests, and the delegates to the inaugural session of this workshop on application of remote sensing and GIS techniques. In fact, it's a high time that such an event took place to highlight the remarkable contribution that remote sensing and GIS applications make in the management of water resources, environment, and other natural resources on the earth. We all know that availability of data for hydrological and water management analysis is a matter of great concern, especially in developing countries like India. And remote sensing coupled with GIS is a powerful tool that offers many advantages in planning, analysis, and sustainable management of water resources. While remote sensing provides spatial and temporally consistent information on hydrological variables, the GIS integrates the spatial analytical functionality for providing spatially distributed data. And nowadays, remote sensing and GIS techniques are being increasingly used in sustainable management of water resources, including runoff and hydrological modeling, flood management, watershed management, drought management, and management of irrigation in command areas. The spatial information on land use categories, soil properties, topography, watershed geometry, drainage network, etc., that are derived using remote sensing and GIS techniques form an important input in distributed hydrological models. Remote sensing can provide attribute data of suitable spatial resolution, which is extremely valuable as model inputs. Similarly, space technology has made substantial contribution in every aspect of flood management, like preparedness, prevention, and relief through floodplain zoning and flood inundation mapping. Assessment of soil erosion and reservoir sedimentation, inventory of irrigated land, identification of crop types, crop extent, crop condition, and estimation of crop yield, mapping of water bodies, etc. I mean, there are many areas where remote sensing techniques are immensely helpful. So workshop such as this provides a valuable opportunity for the researchers, academicians, field engineers, specialists, and decision makers to share their experiences. And I am sure we will have fruitful and rewarding exchanges during these 3 days. I wish the workshop every success and hope the presentations and deliberations made during the workshop would be useful to the professionals and users. Thank you very much.
Thank you, sir. Thank you, sir. Now I would like to invite Professor V.K. Verma, Vijaykant Verma, who is the founder, Vice Chancellor of Rabindranath Tagore University, Bhopal, and presently working as a Chancellor, C.V. Raman University, and Director, Core Research Group of ISEC Group of Universities. I give you a warm welcome, sir, and would like to invite you to say a few words.
Thank you, Shalini. When infrared was discovered in 19th century, no one could have thought that social distancing would become the new normal in 21st century, and an international workshop on remote sensing would be conducted actually through remote mode on a virtual platform like this. That was, of course, on a lighter note. Good morning, good afternoon, and good evening to all dignitaries and delegates, because we are all in different time zone on a virtual platform talking to each other remotely. In India, it's evening, and in USA, it's pleasant morning, as Professor Singh told me. If you recollect, vital technologies like remote sensing, GIS, GPS initially came up with military interests and application, but they have subsequently provided great human service and welfare initiatives and governance tools in civil areas as well. Over the last few decades, fields of remote sensing and GPS linked with GIS have become very exciting. They have provided rapidly expanding opportunities, vital tools, database models, and decision-making systems in almost every area of human endeavor. Right from agriculture to forestry, water resources to land usage, governance to socio-economic activities, you name an area and you will find remote sensing and GIS playing a very, very vital role. Today's international conference is touching four most important areas which are vital for survival of human beings: water, environment, land, and society. As a matter of fact, they encompass everything. Timely and accurate decision in these four areas can bring in sustainable socio-economic development, growth with security, conservation and management of natural and other resources. The data produced and information base generated by remote sensing, GIS and GPS are so accurate, precise and timely that if analyzed and modeled rightly, can bring in sea change for sustained and fast development. Now technology is growing so rapidly that accuracy of decision taken are becoming very high. That is why now every day millions of decisions are being taken world over based on models and analysis powered by GIS and remote sensing, clubbed with powerful technologies and tools developed using big data, IoT, etc. GPS is of course American system, but there are three more countries which are members in this elite club with similar system: China, Russia, and fourth one is India with its NAVIC system. I am happy that Rabindranath Tagore University, Dr. C.V. Raman University with many other organizations have organized this most important workshop, in which very eminent and highly competent professionals from field are going to share very critical and useful information and their research outputs. This is the era of collaboration, and this workshop is live example of collaboration at national and international level. In this pandemic COVID time, remote sensing and GIS has helped in many ways. It has opened new opportunities for epidemiologists to study and identify health black spots. Prevention and health empowerment initiatives and disease care are some of the areas in which modeling, analysis, and decision-making system were made using GIS and remote sensing. Hopkinson University, Federal University of Petroleum Resources, and many other organizations have done a lot of job in this. ISRO of India has made 13,000 satellite passes during last 6 months, giving 2 lakh data product in last 6 months in the health area. All have done a lot of work. IDW, that is inverse distance weighting method, has been extensively used for this in GIS programming and mapping. I'm sure this workshop will excite, inspire and motivate everyone, and new collaboration and new initiative and research will emerge from here. I congratulate all the organizers, conveners and sponsors, and most importantly over 2,000 participants. I'm sure next 3 days will be very, very exciting and useful. I congratulate everyone. All the best. Thank you.
Thank you, sir. Thank you for highlighting the areas for the use of GIS and remote sensing worldwide and initiating the collaborations from all the universities. Now, I would like to invite Srimati Urmila Shukla ji, ma'am, who is a director of Valmi, which is a premier autonomous institute working in the field of natural resources and management as a part of Panchayat and Rural Development Department. Under her dynamic leadership, the institute has gained awards for excellent contribution in the field of natural resources conservation and management. I invite you, ma'am.
धन्यवाद शालिनी जी। माननीय मंत्री जी मध्य प्रदेश शासन, श्री ओम प्रकाश सकलेचा जी विज्ञान एवं प्रौद्योगिकी, श्री संतोष चौबे जी, श्री वीपी सिंह जी, डॉक्टर जेपी त्यागी जी और सभी सम्माननीय अतिथिगण, डेलीगेट्स, मैं आप सभी को नमस्कार करती हूँ तथा मैं आयोजक गणों को बधाई देती हूँ कि उन्होंने एक अभी समसामयिक विषय रिमोट सेंसिंग और जीआईएस पर एक मंथन कार्यक्रम रखा है, एक वर्कशॉप रखी है, जो कि आज के समय की एक अत्यंत आवश्यक विधा है, जिसे कहना चाहिए मेथड है। और वैसे तो मैं जहां तक आप सभी को बताना चाहूंगी कि मैं जीआईएस के विषय में उतना फेमिलियर या टेक्निकल नहीं हूं, किंतु मेरे जो संस्थान है इसमें हम ये कोशिश कर रहे हैं कि हम जीआईएस और रिमोट सेंसिंग के जरिए सभी आम लोगों तक इस मेथड को पहुंचाएं, जिससे कि सभी बड़े फेमिलियर तरीके से इस मेथड को यूज कर सकें, अपने कार्यों में को सुगम बना सके। अभी तक ये परंपरा रही है कि जीआईएस और रिमोट सेंसिंग हम जो थोड़ा सा अपर लेवल था, टेक्निकल लेवल था, वहीं तक हम इसको सीमित रखे हुए थे, किंतु आज एक सिनेरियो बदल चुका है, जैसे कि मेरे पूर्व वक्ता जो हैं उन्होंने भी बताया हुआ है कि ये एक पेंडेमिक दौर है और पेंडेमिक दौर में हमें बहुत सारे काम सोशल डिस्टेंसिंग को मेंटेन करते हुए रखना है। तो हम सभी लोग ये चाह रहे हैं कि हम ऑनलाइन जाएं, हम रिमोट के जरिए यहीं बैठे बैठे हम पता लगा सके कि फिजिकली फील्ड में हो क्या रहा है। तो यहाँ विज्ञान के क्षेत्र में, एडमिनिस्ट्रेशन के क्षेत्र में, एग्रीकल्चर के क्षेत्र में, एनवायरनमेंट के क्षेत्र में, सभी में हमें बहुत जरूरत है अभी। आज की ये एक अति आवश्यक हमारा कार्य है। तो हम कोशिश यही कर रहे हैं, हमारी संस्थान बहुत इस तरीके के कार्य करने की कोशिश कर रही है कि हम सभी जीआईएस और रिमोट सेंसिंग को जन जन तक पहुंचाएं, और इसके लिए हम सभी को यहाँ पे हम प्रशिक्षण प्रदान कर रहे हैं। और मैं आभार प्रकट करूंगी श्री यादव साहब का कि जब वो मेरे पास आए और उन्होंने मुझे इस विषय के बारे में जानकारी दी कि हम ऐसी वर्कशॉप करना चाहते हैं, तो मेरे संस्थान ने, चूंकि हम भी इसी फील्ड में काम कर रहे हैं, उनको सहर्ष अपनी सहमति दी। और इस इंटरनेशनल वर्कशॉप के माध्यम से हम ये सोचते हैं कि आपका जो 3 दिवस का ये पूरा कार्यक्रम चलेगा, इसमें हमारे सामने और नए नए सजेशंस आएंगे, नए नए पॉइंट्स आएंगे, जिनके जरिए हम और सरल तरीके से और सुगम तरीके से इसको आगे अपने विकास कार्यों में उपयोग कर सकेंगे। मैं जो मेन आयोजक हैं यहाँ के रविन्द्रनाथ टैगोर यूनिवर्सिटी के श्री संतोष चौबे जी, उनको, सीवी रमन यूनिवर्सिटी के सभी लोगों को, सभी को हार्दिक धन्यवाद देती हूँ कि उन्होंने मुझे एक अवसर दिया कि मैं इस इंटरनेशनल वर्कशॉप में अपने विचार रख सकूं। मैं सभी के लिए धन्यवाद देती हूँ तथा शुभकामना व्यक्त करती हूँ कि सभी आगे भी इसी प्रकार हम इस तरीके के एक मंथन, सोच और अपने विजन को आगे बढ़ाते रहेंगे। धन्यवाद।
थैंक यू मैम। Thank you for Water and Land Management Institute plays an important role in utilizing the tools of GIS and remote sensing, which Srimati Urmila Shukla ma'am has highlighted by explaining the work which is carried out by the institute. I would also like to thank her for making possible collaborations in the near future regarding different projects. Now I would like to invite Shri Santosh Chaubey Sir, Chancellor, Rabindranath Tagore University. I welcome you, sir, and invite you to say a few words. Shri Santosh Chaubey ji.
शायद मैडम
Okay.
नहीं
Yes.
join किए.
Due to unforeseen reasons, it seems that he is unable to attend the inaugural session. So on his behalf, I would like to invite Vijaykant Verma sir to say a few words on his behalf. VK Verma sir, please unmute yourself.
Thank you, Shalini. On behalf of Shri Santosh Chaubey, I will convey best wishes to all the organizers and delegates and speakers. He is sure that these 3 days workshop will come out with very, very important research outputs, and this platform will provide a beginning to share research outputs at international and national level in such a big way. I think it is one of the rare occasions for Central India to organize a workshop on such a very, very vital subject, and on which there is a lot of work going on, there are a lot of research being done, and it can serve the humanity in a very, very big way. And in a pandemic situation where social distancing is so much norm of the day, the remote sensing and remote virtual platform workshops like this will play a very, very vital role to bring people very close, keeping social distance. I once again congratulate all the organizers and participants and hope they will have a very great time for next 3 days, and it will benefit the entire world. Thank you very much.
Thank you, sir, for conveying the message on behalf of Chancellor Shri Santosh Chaubey sir. Now I would like to invite Shri Om Prakash Sakleja ji. He is a cabinet minister, Department of Science and Technology for MSME, Madhya Pradesh. I give you a warm welcome, sir, and invite you to grace the occasion with few words. Shri Om Prakash Sakleja, sir.
I think, madam, he has earlier joined, but I think he is not there in the meeting. He is not there.
Yes, sir. So now I invite Mr. Ravi Galkate, Scientist and Regional Head, National Institute of Hydrology, Bhopal, to deliver vote of thanks to our honorable guests.
Thank you, madam. Respected guests, speakers and delegates, I deem to great honor and privilege to propose the vote of thanks on behalf of the organizing committee of the International Workshop on Application of Remote Sensing and GIS, Water, Environment, Land and Society. We are extremely happy to express our thanks to our Honorable Science and Technology Minister, who is not able to attend this meeting, but we are thanks for his cooperation to organize this workshop. And we are extremely thankful to our special guest, Professor Santosh Chaubey, President AGU and Chancellor RNTU, who could not attend the meeting, but he has sent his message for this workshop. We are extremely thankful to Professor V.P. Singh, A&M University, Texas, and President of IAVs for his presence and extending support to organize this international workshop. We are extremely grateful to you, sir, for sparing your time out of your busy schedule and giving us the word of appreciation, suggestions, and recommendations. We are extremely happy with the august presence of Srimati Urmila Shukla, IAS, Director Valmi, Government of Madhya Pradesh, Professor Vijayakant Verma, Chancellor, CBRU, Dr. Jaivir Tyagi, Director, National Institute of Hydrology, Government of India, Dr. Avinash Kumar Srivastava, Director, CSR MPRI, Government of India, Dr. Gerard Augusto from IHE Delft, Netherlands, Dr. B.P. Pethia, Vice Chancellor, RNTU, Dr. H.B. Raghavendra, VCC NCU, who could not make it today to attend the function, Dr. R.P. Dubey, Vice Chancellor, CVRU, Bilaspur, and our special thanks to Dr. R.N. Yadav, Vice President, IAVs, for his august presence in this inaugural function. We are all thankful to all invited guests join this function. We have invited guests from NIH and all other organizations here today. We express our gratitude to all the eminent speakers from India, USA, Tunisia, Uganda, Greece, who have accepted our invitation to deliver lecture and share their expertise, and also the scientists, senior scientists who have accepted our invitation to be the chairman and reporter of the various sessions. We are extremely thankful to all the participants from all over the world who have registered for this workshop and those who are watching live streaming on the YouTube. We are thankful to all the organizers and partners of this international workshop on remote sensing and GIS, that is IAVs, International Association for Water, Environment, Energy and Society, IHE Delft, Netherlands, Rabindranath Tagore University, RNTU, India, Bhopal, National Institute of Hydrology, Roorkee, India, Advanced Material Process Research Institute, AMPRI, Government of India, Water and Land Management Institute, Government of Madhya Pradesh, NCU, North Cape University, Gurugram, CVRU, Dr. C.V. Raman University, Bilaspur, for their continuous support in organizing this workshop. We hereby extend our thanks to our organizing team, Dr. Vivek Bhatt, Dr. Shalini Yadav, Dr. R.K. Jaiswal, Dr. J.P. Shukla, Dr. R.K. Singh, and Dr. Manish Upadhyay sir, and others who have directly and indirectly supported and extended help and involved in this function and workshop, and extended their support to this workshop. Thank you very much, ma'am. Thank you very much.
Thank you, sir. Now, thanks for expressing your thanks to all the honorable guests, participants worldwide, and the delegates and the organizers. Now, I would like to invite Dr. Sharad Jain, who is an eminent scientist, National Institute of Hydrology, Roorkee, in the area of water resource management, remote sensing, and GIS. I would like to invite him to chair the session for today's program.
Hello, am I audible?
Yes, sir, you are audible.
Yes, sir.
Okay, thank you, Dr. Yadav. It's a pleasure to be here and see many familiar faces, many well-known people for this important workshop. Now, this session was supposed to start at 17 hours, so we are almost in time. And I understand that there are 4 speakers in this session. I think there is some echo in the voice, so delegates who are not speaking may please mute their mics so that we don't have the problem because of echo.
सर आपके यहाँ से कुछ साउंड की प्रॉब्लम हो रही थी? There is some sound noise.
Am I audible?
Yes, sir, you are audible, but some
there is some echo.
Echo is there from yours.
I think it is less now.
Yeah. Some other devices also, I think, on. Okay, sir, continue, please.
Yeah, so we have 4 presentations. Do we know whether all the authors are present? All the presenters are here. Professor P.K. Joshi, Professor Chander Kumar Singh, Dr. Joseph Kerski, and Dr. Pandey. I think there is no response.
Sir, I think you are logged with the 2 devices at the same time. So this might be the reason of the echo that is coming.
Oh, logged in from my mobile.
Sir, you can switch off your one device, sir. So that, okay, sir.
Let me switch off my
any one device, sir.
Yeah.
Or just mute one device, any one device. You can keep 2 devices on and keep one device mute.
Oh, I was using my mobile that I have switched off now. So,
yes, no issue.
So now then I'll invite Professor P.K. Joshi for his talk on geoinformatics for contemporary environmental issues. And Professor Joshi, you might speak for about 20 minutes and then we will have time for question and answer. So Professor Joshi, please yourself and you can start sharing your screen.
Thank you very much. And if host can kindly enable screen sharing.
You can share the screen, sir.
It is giving me message host disabled participant.
Okay, Sukan.
So now you are a co-host, you can share now, sir.
Okay, it has come. Thank you. So good evening to all, and many thanks for inviting me to share some of my views on application of remote sensing and GIS. I'm basically an ecologist and work in the area of environment, land, and try touching upon society as well. So for today's evening, in front of such a luminary speakers and seniors come wide spectra of researchers come experts, I am sharing some of my views on geoinformatics for contemporary environmental issues. While speaking about this tool, technology, science, I would like to re-emphasize the fact that data is the oil of the 21st century. And when we talk about data, we get data from whole range of sources which could be used and which have actually helped us to understand many of the things which are happening around us. And among these all, Earth observation systems have actually become something much more powerful, which have revolutionized the entire concept of data in much more bolder way. This being real-time, dynamic, in many of the cases open, reusable, and talking about the action research. So you talk of any of the challenges, whether it is SDG goals, Pandey framework, or many bilateral, multilateral agreements at the behest of IPCC, people have always found that Earth observation system is one of a very powerful way of assessing things, monitoring, and also communicating. This story probably started somewhere in 1946 when for the first time through space the Earth was viewed. And when Earth was viewed for the first time, people got courage that Earth resources could be mapped, monitored using this wonderful means. And that has actually revolutionized the way of looking at Earth remotely. And space remote sensing has actually taken a leap since then. And today what we see, roughly 2000 plus satellites are around the Earth's surface, and they are monitoring. They could be polar, they could be geostationary, they could be near, geostationary LEO kind of concept. And most of the countries, to best of my knowledge, around 95 countries in the world, they have the means to have their own satellites. And out of those, roughly 15 countries have the means to launch these, satellites and place them in the orbit. And India earns one of a very high repo when it comes to space remote sensing and all. And these all satellites are providing us, edge to see, understand, and also take decisions related to many of the environmental issues which we see. So generally, people refer to remote sensing as one of the data collection tools or technology. And GIS is a platform where, data set which is coming as an input from remote sensing or from other sources, for example, legacy data that could be processed and that can help us to, simulate or to see the spatio-temporal patterns for better understanding of the things which we are with. And thanks to GPS, though it started with Department of Defense of US, but it was somewhere probably in late 1998 when it actually became something very common for civil purpose. As Brahma Prakash ji was talking about, now many of the countries, including India, China, Japan, they have their own set of GPS satellite. It means you have much better accuracy and much better accessibility to location. So this all, remote sensing, GIS, GPS together with ICT and, strong ground knowledge that builds up a discipline which we generally call as geoinformatics and which can help us in many of the ways. In India, the first remote sensing application which is documented started somewhere in 1970s. One of a former scientist from ICR, Sir P.R. Khrushchev, he carried out an experiment on coconut root well disease, and he, through his study, it could be seen that false color composite along with black and white photographs, one can detect something which is very important to be looked at while looking at natural resources. This was the beginning of remote sensing application in India. And then subsequently, the first national application comes to forest cover mapping with a group of scientists, one Professor P.S. Roy, in a given time of 6 months, could map the forest cover of entire India. And people who understand cartography, thematic mapping, and these kind of challenges for such a magnificent country, doing such kind of mapping was one of a challenging exercise, but it was done with a very high degree of commitment and which has given the pathway for most of the activities in the country in and around natural resource management. And today what you see forest resource management, urban resource management, land information system, you name it, any of the thematic area or subdisciplinary thematic area, you get to understand that country is developing database using remote sensing, analyzing that and providing scenarios using GIS, and which is always being supported with GPS. And the technology is changing very fast, and now we are in a world of open access tools or open data set, wherein you get to see most of the data set which are archived by NASA are openly and freely available. And there are many of other countries, including European Space Agency and a few more examples where such kind of data sets are being openly available. We are living in a world of open geospatial consortium, wherein, softwares like Quantum GIS, Diva GIS, Ilves, Saga GIS, there is a whole range of list along with many of the extensions which are available, so that the data or the platform, which was one of at one point of time very costly affair and out of reach of many of the researchers, now it has come something very close to all of us. And we all are talking about cloud GIS now. Google Earth Engine has come with a altogether different type of configuration, wherein data as a service, software as a service, and platform as a service, PaaS, DaaS, SaaS has come into picture. And people are able to use such kind of data set for land use, land cover mapping, forest resource assessment, crop mapping, you name it, all those kind of things are available there. Plus, people are also in process of developing algorithms of data pre-processing, which becomes something very important part of any of the satellite data processing. So what I'm trying to tell my audience is that today most of the data sets are openly and freely available through Google Earth Engine, and people are able to develop or customize applications as per their research requirement and also operational activities. And this number which shows here, this is from a systematic review, which tells us that how Google Earth Engine has been exploited or explored for different type of thematic applications. And many of such kind of data sets which are being generated, those are freely and openly available. You name any kind of data set, you will be able to find it there on the web. You just need to know how to use that data. So for me, data which was supreme for so many decades, and people used to say data is king, today I say that context is God. We need more of a research questions, proper research questions, what to do, because data is already available there, and one should be able to collate such type of wide range of data sets. People can always argue with respect to spatial resolution. Yes, there is some kind of limitation with the data sets which are there, but still anything and everything which is coming up with many of the space agencies, those are getting populated in the open platforms. And when we talk about these front end tools or frontier tools, many a times people feel as if only a part of the world is equipped or is able to do such kind of things. But this systematic review tells us that most of the countries around the world, you simply can't just say that developing countries are able to do it. Even the upcoming countries, and they are very much into such kind of things, and we need to look at how such kind of things could be made much more accessible. Now the science has all come to very close to centimeter kind of spatial resolution with Cartosat, Cartosat 3 with 25 centimeter of spatial resolution, and with a very powerful agenda of crop insurance and all. Now technology has actually gone onto the ground to map and measure the land in centimeters, and people are talking about crop insurance at the behest of science of precision agriculture, so that they can understand things in much more closer way, and decision making could be very powerful. And with such a high temporal and spectral resolution, people are trying to attempt species mapping, endemism, rarity, abundance, when along with health of the vegetation. And those days have actually gone where people were just happy with the change detection kind of stuff. Now the technology is with the availability of LiDAR and 3D modeling, technology is able to help you to identify the gap areas and see a kind of fly through over the landscape and actually identify where the gap areas are, and then accordingly fill them in terms of afforestation and reforestation. We have a wonderful example from Karnataka Forest Department and also Haryana Forest Department, wherein drones and UAVs were used in a real-time monitoring of gaps and then actually mapping these things. This technology is also able to give us, information about something which were relatively very unknown. This one of the species wherein it was always felt that lion is the one who is spending time in mating and luxury kind of stuff, and lioness is the one which is carrying out all work for taking care of families and all. This is how behavior, wildlife behavior were talked about. But what people can do today is people can actually color both male and female lion and actually see their hunting view shed. And it tells us that male is much more strategic, which goes undercover kind of operation, unlike the lioness, which goes in the open savanna for hunting. And that was giving us a kind of different attribute in terms of wildlife behavior. I'm just sharing with you about lion, but there are wonderful examples from other wildlife species also, which is uncovering many of the newer truths to all of us. We all know, fire, though from forest areas or agriculture areas, what we see just close to Delhi in Haryana and Punjab. These all things were talked about. And now people are trying to move forward, trying to see how such kind of incidences or maybe activities, when I talk about forest and agriculture respectively, is getting related with, human health, pollution, mortality. So such kind of fires are getting connected towards to the health and for better understanding on, air pollution and related health issues. People are trying to look at, a philosophy of source proportionment when AOD is being talked about, whether it is from biomass burning or it is just from dust or haze. So the capabilities have actually enhanced. People have taken a leap from an earlier set of sensors, including MODIS, and entire Copernicus program has come with NOx and SOx kind of monitoring, in addition to AOD and particulate matter. So, the entire philosophy of utilization of satellite remote sensing to air pollution and water pollution has actually changed. What people are doing is people are more interested to look at location-based services and trying to, populate the data set from GPS, GIS, and generating such type of 3D models. We did it for Panji, wherein, we tried simulating the urban flooding and then trying to tell the municipal commissioners that how your resources are overlaid on the landscape, whether it is industry, police station, school, hospitals, or any kind of amenities or services, and what kind of impact of urban flooding is there, which are the zones which are relatively much more secure, and the zones which might have, greater degree of danger in terms of excess of rainfall or even being a, coastal city because of cyclones and all. So the human life tragedies, those have actually come into single digit. What we are more worried about is how the environmental resources or infrastructure could be managed in case of such type of disasters and episodic events. So that is what high resolution data set and location based services are giving us. People are also talking about renewable energy in a very louder sense, and we have wonderful examples from different parts of the country wherein solar panels are talked in a very operational way. What we tried doing is we tried looking at a very high resolution data set of close to 1 meter resolution and map each and every rooftop of a city. And then for each of the rooftop, we actually know the heights of the buildings, and if there is any tree, and you can actually click on and get to understand what kind of kilowatt hour per square meter per day kind of solar radiation is available. And if you click on this, you can get to see it weekly and even daily kind of thing. And this is one of a operational event which is available in Google Play Store. You can go to something called as SPV for all, and you will get to see this app wherein you simply click on your rooftop and you actually understand what kind of area is available. You decide on what kind of rooftop you want to use, whether 50%, 30% and all. And similarly, the kind of technologies which are available as on date. It precisely gives you the break-even point. What kind of investment do you need and what kind of break-even point you can achieve. So that way, technology is serving the day-to-day decisions, and this is one of a very important activities which most of the developing countries have taken up, and we wish to take it forward to the rural areas also, so that they can identify their rooftops and actually see it. So as I said, this technology is changing very fast. Now the days have actually gone wherein you will be launching 20 satellites or 30 satellites in one launch vehicle. Rather, as a packet, hundreds of satellites will be coming at. we are moving towards something as ultra remote sensing and micro satellites kind of event, so that you will be having a almost real time, continuous, consistent, high spatial, high temporal, and wide spectral resolution data set available with you. Now, it is up to you and I to think in a broader sense with such a huge amount of big data concept coming up, how we can use it. You know, one of the things could be you wait for COVID and look how high resolution data sets tells you about what kind of dynamism is there in terms of pilgrims and all. And this is how, Maxar images were being used. Or you try to discover what Harvard research carried out while working in some of the hospitals of China, and then pinpointing that the COVID, which we all are talking about, it actually started there in August 2019. Whereas recently there is another publication which has come from Chinese scholars, which are, pinpointing towards Indians that, it has started from India. So that is altogether different story. But what I am trying to tell you over here is, with such a high resolution data set, one is able to see the frequency of visitors and the time periods when that visit has actually increased, so that you can actually see when and where such type of needs have actually occurred. So this is how very high resolution data set is being explored. People are hinging on location-based services, where countries, democratic countries like India are debating whether it is a physical distance or social distance. There are people in Denver who are actually looking at whether there are few people than normal or more people than normal, simply to identify the hotspots of mobility, and then actually looking into where and how this COVID incidences might get surged up. So this is how location-based services are being looked at, and people are developing such type of things. This is nothing very new for many of the government agencies in India. Like DST has actually exploited and explored all the potentials of UAVs during and drones during this COVID-19. There was an entire dashboard which was actually looking at many of the real-time streaming which was being collected through drones and UAVs. People were actually looking at if thermal scanning could be exploited and could give us better understanding than that of just lockdown patrolling or providing services and goods for the delivery and all. So it is all up to you and me to look at more or explore a larger catchment of application of remote sensing inputs or GIS platforms for better understanding of what is happening to all of us. Like this is another wonderful example which one of my colleague at ICRADA, he has tried developing at looking at Google Earth Engine and then actually pinpointing when and where harvesting took place. So this is for 2019, this is for 2020. So what this first cut analysis tells us that the crop harvesting has actually delayed in 2020. It might have many of the biophysical reasons, but more so also social reasons. And if you rely on this, then we actually know how a piece of land is available in terms of fallow. And specifically, this is very significant when it is fallow after the paddy crop, so that the moisture which is available there in the land could be optimally utilized. I don't say potentially utilized, I'm saying optimally utilized. So if such kind of, and databases could be looked at time and again, we can actually look at the optimal utilization of agriculture fields and even add to something, a challenge of food security, in addition to talking about migratory laborers or movement of people from one location to another location in the incidences like COVID. So data sets are available. We just need to look at how such kind of data sets could be further processed to provide a similar kind of information. It can actually, you can look at district by district and then synthesize better information so that local administration can take maximum benefit out of such kind of tools. And before I close, I urge all the Indians listening to me, Arogya Setu is nothing but the location-based service which is developed on the concepts of GPS and GIS. So if you are here to learn this technology and wish that you can use this technology, probably this could be your first step to marry the technology. And I don't say it is the best app which is available, but I'm very much confirmed if we all use this app, probably we can draw newer, levels for improving such type of apps and bringing much more realistic applications for the well-being of society in such a pandemic time. So I stop here, and if audience have any question, I will be happy to answer those, provided I actually know how to reply. Thank you very much.
Thank you, Professor Joshi, for a very nice talk. You have very rightly said in the beginning that data is oil. There is another similar view that data is God. You have also given history of remote sensing. You talked about open data sources, spatial resolution, hyperspectral remote sensing, satellites like Hyperon, etc. And then you talked about application of remote sensing in various domains. Now, there are some questions in the chat box that I can see. There is one question about data sources. So let me mention that for India, we have a site called Bhuvan, which has huge amount of spatial data. For water sector, we also have a site called VADIS, Water Information System, which contains hydrological data and river flow data. And of course, as Professor Joshi mentioned, Google Earth Engine combines huge database as well as analytical tools. Now, there are some more questions related to how this remote sensing can be used and what are the social benefits. So, Professor Joshi, would you like to answer this point? Although you have covered social benefits, you have covered environmental applications in greater details, but still, would you like to say something more here?
Any problem which has a geographical context could be addressed using GPS, GIS, and inputs can be gathered from remote sensing. Now it is up to you and I to think on what attributes, what variables do you want to extract from remote sensing inputs or populate them on a GIS platform to use those. As Dr. Jain just mentioned about, there is VARIS, there is Bhuvan, there is Google Earth Engine, whole range of thematic and non-thematic data sets are available. We just need to bring them onto a proper sequence so that we can answer many of the questions. Like the recently popped up question is related to a micro watershed planning. So with a very high resolution data and DM which is generated by Cartosat kind of special resolution, such kind of possibilities are very much there. And there is a whole range of watershed monitoring program which is there in Uttarakhand we are doing, and we are using such type of high resolution DM for micro watershed planning. So that is very much doable.
Very good. Great. Are there any more questions? Yeah, there's one question for organizers, and some people have asked for sharing of PPTs. So Ravi, would you like to respond, or Dr. Shalini Yadav, would you like to respond? How these PPTs, what are the plans to make them available? Are you thinking?
Sir, definitely, sir, we have got the email of all the participants, and we will request our speakers to send us the PPTs and that can be shared with the participants.
Sure.
Shalini madam?
Yeah, so with the consent of speakers, maybe PDFs or PPTs can be shared with the delegates.
Right.
Are there any more burning questions that you would like from Professor Joshi?
People are interested to know about Cartosat. It is at the behest of National Remote Sensing Center, and they have also prepared a wonderful DM using that. I don't say it is freely available, but it is openly available, and with a degree of understanding and agreement with NRSC. that could be taken from him. And Bhuvan can be one of the gateway to look at such kind of data sets, and it provides you to download some of similar kind of databases, including thematic maps for experimental purposes. And based on your understanding about such kind of data set, you can always look to NRSC to get more details on that.
Okay. Thank you. So thank you, Professor Joshi, for a very nice and interesting presentation covering very vast swaths, I can say, the environmental field. We would now move to the next talk, which is specifically focused on water. The speaker is Professor Chander Kumar Singh, and the topic of talk is application of remote sensing in water resources management. Before inviting Professor Singh, can I also request Dr. Shalini, if you can, watch the chat box and maybe find out what are the questions and club them together so that we can have very focused questions to the speaker on behalf of participants. I think that would be helpful.
Definitely, I'll just browse the chat box and we'll sort out only 1 or 2 questions, and the rest of the questions will be answered to the participants through the email.
Thank you. So now the floor is to you, Professor Singh. You may start.
Well, very good evening to you all, and good morning to the participants from abroad. I am happy that I'm given an opportunity for my work related to water management, wherein we do apply a lot of geospatial techniques in solving certain of the problems. Hope I'm audible to you all.
Yes, sir, you are audible.
Okay,
you may continue.
Thank you. Okay, so to start with, I'll just take it from the last presentation, and also it happens to be a kind of opportunity for me to be speaking after Professor Joshi. So he's been my mentor also. So to say from there that when we talk about geospatial technology, it's basically we try to problems because they are spatially related. And to give you a very, very simple example on why do we need to consider this entire Earth as interrelated, because most of the processes that impact, be it natural processes, be it anything related to climate, atmosphere, these are all interlinked. And a very simple example you can observe is a process of air circulation or ocean circulation that you see around the world that keeps on changing the climate, that is responsible for maintaining the temperature, ambient temperature that is required on Earth. So we see that most of these things, any activity place upstream or downstream, is going to impact each of the process that we see or each of the resources that we find nearby that particular area. So most of these are actually interlinked to each other. And if there is a problem, we need to think more spatially, more say location-based solutions, so that when we rectify a problem at one particular point, it also gets the benefits of that kind of improvement or say intervention that is taking place is also going to impact the areas which are interconnected to each other. So because I am going to talk about water resource management or say water management perspective, I'll try to start with why do we need to think of water management. So to give you a data around the world, if you try to see, it's a very, very kind of figure which seems to be very disturbing in a sense that 1 billion people have no access to safe drinking water. Now, in the times or in the current times of this crisis, or say the pandemic, wherein the solution that is to be thought of as on date is, we have been seeing a lot of agencies talking about cleaning our hands, washing our hands through soaps, and all of this is required to be done using water. Now, when we see if there are certain number, a big chunk of people who are devoid of water, who do not have access to water, how are they going to survive this kind of problem which is currently prevailing around the world? Secondly, if you try to see that 70% of world's fresh water is used for irrigation, and I'll also show you a figure which is again fewer times letting us know that what is that particular sector around the world that consumes water. Why do we need to conserve water from those particular sectors? We'll come to those. But to show you, as of now, on date, if we try to see the global water stress, within a span of 30 years, you see the world map keep on changing. And by 2025, if I try to see the situation that prevails in India, you'll see that India is going to move towards much more stressed condition compared to what was there in 1995, and it will be entirely under stress. That is, more than 40% of the water withdrawal in entire India would be, kind of leading to depleting water resources. Apart from this, there are also certain countries in Africa which would be running dry in certain number of years to come. But when we see in a time span of 30 years, we see that the globe is actually, countries are moving towards a very, very serious kind of situation. And in fact, now there are certain number of countries which have resorted to a kind of techniques or technology which were not thought to be, to be used in circumstances. But as of now, you see the techniques like fog capture, which has become, this fog capture technique is a kind of, wherein people try to tie these nets, and the fogs, they condense on these nets, which flow down the net, and then it is collected into a small pipe which is connected to a water tank you see here. So this is a kind of, the situation has become such worse that people have to rely on such kind of, innovations wherein they are trying to harvest water from air to meet their demands. The second thing you see here is these are again two very starkly different situations. It's a country in Africa wherein people are trying to develop innovations based on the kind of resources they have, where there is a different example you see wherein thousands of billions of dollars have been invested in countries like Saudi Arabia, which are basically oil-rich economies, wherein they have tried to install or establish such a huge kind of desalination plant, wherein the water demands are being met by desalination of seawater. So the situation has become worse. Certainly, it is going to get more worse, because what we see here is not only the consumption or the population that has increased, but there is also a very unsustainable way or practice that people have taken up, which has resulted into such kind of crisis. Now, if you try to see several countries around the world, you'll see that there are, major of the countries which are, fetching water for, industrial requirements. There are certain number of countries which are heavily dependent upon agriculture, and the water which is basically used, at least what you see, the countries which are marked green here in the world map, they are actually agricultural dominant countries, and they fetch most of their fresh water is to meet the demands of the agriculture. So when you try to see the overall, global water use in terms of withdrawal and consumption, what we have been seeing that a lot number of time industries are thought to be major consumers of water, or which are basically thought to be consuming more of water. But the important aspect that we need to think of is the agriculture. If you try to see this particular first graph here, agriculture is something which is withdrawing most of water around the world, and also the withdrawal and the consumption gap is quite wider in terms of agriculture. And when this withdrawal is compared to domestic consumption, obviously the withdrawal is very less compared to agriculture. But if we try to see what is the amount of wastage that is going, which is basically the difference of withdrawal and consumption, you'll see that agriculture or domestic are almost similar kind of, the wastage of water is taking place in by both these sectors, whereas industries doesn't seem to be that major consumer of water. And in fact, the wastage also in industrial consumption is not that high compared to agriculture or domestic consumption. So the need is, we need to adopt certain practices, more innovative practices in agriculture, so that we decrease the withdrawal and the wastage. Similarly, we'll have to think about the domestic consumption and the domestic wastage that is taking place. Now, when you try to see the overall water stress around the world, as estimated as per this business as usual scenario, you find that most of the countries in South Asia, they are going to be under extreme stress of water till say mid of this century. And most of these countries, you'll see they are under extremely high stress condition, wherein the need of water that is required per capita in a country will be so low that even for thinking about having water for drinking would be a kind of situation where we'll have to think about how do we try to meet that demand to satisfy our domestic needs. Now, overall, when you try to see, there are a lot of regions which has developed into such kind of situations. Obviously, climate impacts, or I would say climate variability, has become a major concern. So along with increasing population, climate change, there has become much more stress on this limited resource of water. So what do? We have to think about certain ways of applying technologies or innovative technologies, or technologies which are more scientific in designing or extracting water resources. We'll have to think about those technologies. We'll have to think about applying those technologies in terms of water set management or water resource management. This is a map you see currently as on the slide, that India, which tried to come up with a report on Indian states, finds that most of the metro cities in India are going to be water dry by which were supposed to be going dry by this year end. And it doesn't mean that the water availability will go all, go to zero, as in case saying that the particular region would be water dry. Rather, it's more related to the component, or I would say rather related to the quantity of water that would be available for a person within these kind of cities for consumption. So moving on, we'll see, I'm skipping this slide, which was although interesting. We see that there has been a lot of innovation in technologies, and there has been satellite or platforms which are now able to monitor the groundwater storage or terrestrial water storage around the world. The example you see here is an example that is of a gravity GRACE satellite, which is a gravity recovery and climate experiment satellite, which is basically a combination of two satellites revolving on its orbit at a distance apart. And if there is any change within the mass of the Earth, the satellites are able to detect that smallest change that is taking place within the mass of the Earth. That means if you are trying to extract water from a certain region or overexploit water, basically you are extracting mass out of that particular region. And if there is a slight change in mass, the gravity would also change. I hope you remember that the gravitational force is basically a product of mass of Earth and the mass of the object. So that's where in gravity is basically measured to estimate what is the amount of water that is lost from a particular area or a region on the Earth's surface. This is a study which was published in 2009 by a group of US, which basically talks about the northwestern India as a region which has depleted a huge amount of water resource. And basically the region you see here on the screen in India is a region which belongs to desertic part of India. Also, within this red region, there is a part of the capital city of India, that is Delhi, which has gone under extreme stress. And such kind of monitoring or monthly observations are helpful to see which are the regions which are going under heavier exploitation and which should be conserved wherein we should apply certain kind of interventions so that we can conserve water resources. This is again a study which basically talks about the vulnerability that we try to see in the entire Himalayan region, which covers, and certain countries in Asia, which basically is talking about Pakistan, India, Afghanistan, Bangladesh. And what we find from this study is not only water depletion, but there are also areas which are having certain kinds of water quality problems. So both the problems, when they are coupled together, what we see here is the map you can see, observe on the screen here is that the most of the regions which are marked red are basically having kind of water, even if that is available, that is not suitable for domestic use. And that's, again, as I say, it's a combination of remote sensing as well as GIS. It's more of an amalgamation of both the techniques together to find out which are certain patches which are going to be depleted or which are not good for use for domestic use. So that kind of areas could be spotted, and accordingly there could be certain policy decisions that can be taken up in those regions of high risk. This is again a study which was done in a very, very rocky terrain and to see or establish if there is a possibility of water resource that could be exploited. So what you see here is it's a combination of geophysical, GIS, and remote sensing technology, which has been integrated in the entire approach. And what we did was a 3D view of the area was generated, and this 3D is basically to identify which are the areas wherein we can find the cone of depression, or I would say, if you are to see a three-dimensional view of the region, you can identify which would be the regions wherein the water would be accumulating while there is a rainfall or precipitation taking place. If that is how we try to define different depression areas, and based on this depression areas, we try to estimate what are different, the NDVI, which is a kind of factor which could be estimated using satellite data, wherein NDVI is basically a index wherein you can estimate the vegetation vigor, that is the capacity of vegetation to grow in that particular patch. If that's increasing over the years, then there is certainly a possibility that vegetation is fetching water from somewhere in this area, and those areas would be a kind of indirect indicators of presence of water in these patches. So you'll see here it's a NDVI map that has been generated, and then there were certain ground-based instruments that were deployed to see what is the resistivity or resistance within the area, because the current is easily able to flow into water kind of stuff compared to different rocky surfaces. So if you try to make the current flow through the surface to the ground surface, below the ground surface, whenever the current encounters water, the resistance that is offered to the current would be lowest compared to the rocky surfaces. So wherever the resistance drops, that means there is a possibility of water that would be existing. And based on these several indirect measurements, be it remote sensing, be it GIS based, be it geophysical based, certain patches were identified. And as I said, it's a very, very hard rock area in National Capital Territory of India. And based on that, we were able to develop a three-dimensional aquifer model of the region, wherein we have also estimated what is the thickness of the water that is available in this particular region. You can see it's along the entire region. There were several wells that were drilled, and the water was observed, and obviously you can see the thickness of water changes from one direction to other based on its availability or presence within that particular area. So that's a very, very typical example of integrating several techniques together to see how we can find out proper aquifer model kind of thing. Then you can see there is certain features which are kind of indicators of water, presence of water. So based on that, you can certainly do a kind of geomorphological mapping, lineament mapping, as these are features or fractured rocks wherein the water is able to flow beneath the surface. So mostly the regions can be pointed out based on these certain features. And if you see examples, you can see there is a kind of oxbow lake here, which is a kind of indicator that the river used to flow from this particular region, but has then left out the course, and this entire region, the course of the river or remnant of the river is there. Similarly, you can identify certain meander scars that are present along the river channels. So these are certainly the regions or kind of features which can give us a sense that this could be explored to fetch new sources of water, which would be certainly much more, reliable or sustainable in terms of its water discharge capacities. Then, well, this is another, technique that is employed in GIS, wherein you try to club together a lot number of different layers to bring them together to identify which are the patches which would be having very high potential for groundwater. So that can be estimated in this region. Certainly, there is another, aspect of water other than quantity, the quality of water. So GIS, in fact, has a capacity to solve certain equations or numerical problems or association between different layers of certain factors. So based on that, you can identify certain areas which are in terms of quality, which would be good, which would be very poor in terms of water quality. Then apart from this, we have been doing a bit of study on groundwater arsenic, which I wouldn't say we try to apply a lot of GIS or remote sensing in this, but certainly there is a social aspect of this, research that I wanted to share with you. And what you see here is, different regions in India which are very, very, estimated to be a kind of having water quality problems. And we have been working a lot in different regions. So what you see here is the spatial distribution of water. That is, when you try to test each hand pump, as I said initially, that the problems are spatially related to each other. So there would be a kind of spatial variability, horizontal spatial variability, or vertical spatial variability in terms of groundwater. And if that kind of information is to be conveyed to the households, so what we did was we tried to test each of the hand pumps, tell the villagers or house owners, and try to plant a kind of plate here which says that water is not safe. And for villagers to learn, to make them learn, you can see these villagers being taught how to read Google Earth maps. And on these Google Earth maps, the location of hand pumps are mentioned, which are blue hand pumps, which are going to be the red hand pumps. The red means which the water is not suitable for drinking, whereas the blue ones are safe for drinking. And the purpose is so that the villagers know which is the nearest safe well to fetch water from, at least for their domestic needs. So there were a number of villagers and villages that were trained to read this, Google Earth maps, so that they can identify if their hand pump or well is not safe in terms of drinking water, which is the nearest one wherein they can go and fetch water from. So that's a kind of social learning that the villagers did. And what we found was, at least over intervention of 5 years, we were able to see at least 53% of the villagers that they move towards safe water resources. So that's again one dimension of thinking on how to empower or raise awareness among the villagers using this technology. So I think that's the last slide. This is our research group. And you can see a lot of drillers, PhD scholars, collaborators here. So that's it, I think, from my end. And Well, takeaways, certainly, as I said, there should be always a, a scientific basis for designing, certain interventions so that there is a proper way of fetching water. Meteorology, we say we need to experiments rather than only doing modeling. So obviously adaptive experiments are a kind of thing which would be able to empower people or even the illiterate or villagers so that they can, come up with certain sustainable solutions for. Well, I'll stop here. Thank you very much, and maybe can take.
Thank you, Professor Joshi, for a nice presentation. You have rightly placed a lot of emphasis on water management, telling about the water stress and consumption of water by different sectors. Your presentation about the GRACE satellite details are very useful. In India, we were aware that a lot of groundwater is being withdrawn in northwestern part, but the Rodal 2009 paper was a landmark paper in the sense that it brought the problem of aquifer depletion to the center stage of discussions. Of course, subsequent studies have also shown that it is best to assimilate the GRACE data with aquifer properties and observed groundwater level data so that we can come to right conclusions, because sometimes GRACE data has been found to give overestimation as well as underestimation. But once more, thank you for your presentation. Now, Dr. Shalini Yadav, are there some questions which Dr. Singh can be requested to answer?
Yes, sir, there are certain questions. One of the participants has inquired about the reasons of arsenic presence in the groundwater. So, Dr. Chander, sir?
Well, the presence of arsenic has been, linked to the sediments that have been deposited long back. So it's mostly within the floodplains of the river, which would have carried sediments from Himalayas somewhere 10-15,000 years back, and these are basically sediments which are rich in iron and arsenic minerals. So these are basically kind of pyrites or iron hydroxide minerals which are present in the sediments. And if we touch upon that particular layer of aquifer wherein these minerals are present, actually supply them a kind of condition so that the arsenic is released from these minerals into water, the groundwater. So mostly it has been found to be in India, at least it has been found to be linked mostly towards, kind of geogenic kind of source. Well, there have been some documented studies on arsenic and water coming from fly ash or those kind of things, but that's not I would say well studied kind of thing. But as such in groundwater, yes, certainly the source is more of a natural origin rather than I would say from outside or anthropogenic.
One of the participants from Ethiopia want to know the open source high spatial and temporal resolution remote sensing sources, which can be used for Africa and Ethiopia.
I think, well, if the participants are to access the data set, mostly it is available from one of the, any one of you can simply Google it as Earth Explorer, which basically is a kind of platform which provides you all the kinds of data which are freely available. And in fact, you can gather data of somewhere, 20 to 30 meter kind of resolution from such open source platforms. Bhuvan is one another site which is more specifically designed for India. So there are, also European satellite data sets such as Sentinel, which is at 10-meter kind of spatial resolution, that is also available free of cost. So obviously, a platform is obviously there that the participants can Google out Earth Explorer, create their login, and then they can certainly look for different kinds of data which are available free of cost.
Okay, thank you. I think it's time to move to the next presentation.
Thank you, sir.
Thank you, Dr. Singh, for a very nice presentation. And now we move to Professor Joseph Kerski. And I find the topic very interesting. 3 forces, 3 trends, and 5 skills critical to GIS and remote sensing in 2020s. I'm sure this is going to be very nice and very useful presentation. And now I invite Professor Kerski for his talk.
Greetings, namaste, everyone. Hardik or Shubh. Myra Nam Joseph Kerski, hey. Maya Colorado, Mai Reta Hu. Mujhe Itni Hindi Ati Hai. That's all I know in Hindi.
Wonderful, wonderful.
But it is wonderful to be with all of you. It is a great honor indeed. I would just like to have us focus on education here for the next segment. Now, Dr. Singh, with his tale and story of getting the students involved in the village about water quality issues, that's really near and dear to my heart as a geographer. So I salute you, Dr. Singh. We are going to be focused on these sorts of topics in the next segment here. I would just ask you all to think about, what do you want to see in society? I realize that's one of the reasons why you all organized this magnificent conference. But I would just submit to you all that geospatial technologies is a way for us to achieve a more sustainable, healthier, happier future, right? That is ultimately why we are all so excited about these technologies. It's not the technologies themselves, it's what we can do with it, right? It's how we can apply it to build a better world. And I am in the education sector of geospatial technologies. All of my research is on the implementation and effectiveness of geospatial technology as a teaching and learning tool. More about that in a bit. But there's a couple of things I wanted us to think about here in this segment, and that is education is going to continue, right? We all have had disruption in society. Education, transportation, environment, every part of society has been disrupted by the health issues that we've encountered this year, correct? But education will continue. In times of disruption like COVID has presented, it's a way for organizations like colleges, universities, etc., schools to restructure how they do things and why they do what they do. So there is some disruption, yes, but there's much innovation happening, and geospatial technologies is a part of it. And geotechnologies themselves, despite articles 20 years ago that said geotechnologies is not going to be a thing in 2020 because it's going to be so embedded in organizational workflows that it won't be a distinct entity. Yes and no. In organizations, as you all are aware, geospatial technologies is seen as a valued asset throughout an organization, a government agency, a private company, a university, for example, and no longer just, oh, you need some maps, you need some geospatial data, go down the hall and see the geospatial people, they'll help you out. That's still a trend, but I think that spatial is still special, right? Spatial technologies, geotechnologies, remote sensing, web mapping, GIS, GPS, etc., GNSS, are still, they still have their own way of looking at the world. And so my focus, and this is a way to contact me, I look forward to future dialogue with you all. My focus is how to help all levels of education be successful with geotechnology. So students, faculty, teachers, deans, university provosts, presidents, and others, okay? And the team that I am actually on, this is a bit of my background, not to go into it in too much detail, but most of it is in federal agencies, like many of you, creating the spatial data that people use. So NOAA, US Geological Survey, US Census Bureau. I'm at Esri now, Environmental Systems Research Institute, on the education team. And I also, like many of you, teach, because I love interacting with students and faculty. So I teach as a GIS professor in several different universities. And I've also worked in nonprofits. So I have sort of toes or fingers in 4 different sectors of society. I'm very honored to be with you all today. The education program here at Esri is, as you can see here, about building this brighter future. And our threefold mission is, as you can see here, education, sustainability, and science. The mission of the education team, again, is to support and promote the use of geotechnologies in a deeper way and in a broader way. The deeper way is we want students to engage in the entire platform, and Dr. Shukla and Dr. Joshi and others already today have embraced this whole platform web-based notion of geospatial technology as it has evolved into the 2020s. And by that, I mean field apps and building web mapping applications and doing some coding that's behind the scenes of all these wonderful dynamic web maps that we've all become accustomed to using, and having students engage in spatial analysis. So engaging in the whole platform, the deeper part of GIS. And the broader part of GIS, as part of our mission, is we feel it's too valuable to be in 1 or 2 departments, for example, in a school or in a university. So I'm a geographer. Many of you are geographer, environmental scientists, climate scientists, etc. And so I'm not going to turn my back on my own people, but I want it to be in business, in engineering, in data science, in computer science, in sociology, in history, in other departments on a campus, because I want those students and those faculty to think spatially, and I want them to engage in at least some segments of this geotechnology platform. It really is a platform, and that's what's exciting about it. Now, at no time in history have dashboards and web maps have been so readily consumed, right? Anybody on the planet with a computer or a phone has looked at the JHU coronavirus dashboard, as well as local and regional and national dashboards that have been set up using these same tools. And why are they doing that? Because they need to make wise decisions about their everyday behavior. And communities need to know what sorts of implementation to put into place where, okay, is a library going to be open? Is a school going to be open? Is a university going to be open? Is our shopping center going to be open, et cetera? So people are using these to make smarter decisions about their behavior and about their community plans. Well, I am very passionate about a issue called walkability. Is a community walkable or not? And many environmental scientists are caring now about that very topic. Is a community walkable? So I have a story map here. It's a multimedia web map inside which I talk about, okay, what is walkability? Who cares about it? Why do we care about it? And inside my story map, I have one of the field tools that I talked about earlier. And this is Survey 123 from my organization. You can crowdsource Survey 123. So you can deploy a survey just like Google Forms or SurveyMonkey and deploy it. And people can gather data into your survey, and then you can map it. So in my survey, I have, is this place walkable or not? Is it pedestrian friendly? Rate the walkability, tick all the choices that describe it. Where is it located? Which is, of course, very germane to our discussion today, right, folks? And do you have a photograph of it? So inside my story map, then, I have the locations around the planet where people have submitted data to my survey. And underneath that, I have what should be familiar with to you all, a dashboard. It's a very simple dashboard getting a feed from one survey, which is my own survey. And I have a couple of pie charts here, right? I have pedestrian friendly or unfriendly. Right now, 2/3 roughly are friendly and 1/3 are unfriendly. And this is one of the attributes that I had people fill out the survey about. And then at the current time, I have 431 survey points submitted to my own survey along with this interactive map and so on. So you can see the power of GIS, right, is the whole idea of a database linked to a map, and it's updated in real time. So in my case, this survey is the same technology as this survey and dashboard. If this receives input from a multiple of sources, mine receives input from one source, but the point is several. It's the same technology. And number two, related to our education discussion, students, faculty, etc., have access to these tools. They can actually do this. This survey and the story map and the dashboard, all told, took me about an afternoon to create. So 4 hours roughly to create all of these pieces. So we're not talking days, weeks, months. And that's the power of modern geotechnologies. So if we go back to the 5 forces and the 5 themes, I would like to submit these to you for your consideration. Geo-awareness is one of the forces. At no time in history has the level of awareness of the issues that you and I and the other attendees of this conference care about have been in the public consciousness, right? People are talking about water and climate and natural hazards and population change and pressure on land use and biodiversity loss and so on, right? People are talking about these. So the level of awareness is at an all-time high, which actually is good for us in the profession, isn't it? And geo-enablement. I used to say to people, have you used your phone to find your way across campus or across your village or to your grandmother's house, etc., right? People use these tools. Now I usually use this example. Have you seen the JHU coronavirus dashboard? So the level of enablement is high too. People are using segments of these tools. And geotechnologies themselves having elevated or evolved into this cloud-based system is a huge leap forward in terms of adoption. So worldwide, we see more and more schools, universities, and other places where education happens, libraries, museums, after-school clubs, etc., using these tools, which is incredibly empowering. In the old days, when we would conduct, for example, faculty training, they would say, oh, you know, I've got to install software now, and I have to work with my IT staff, and I'm not saying that those concerns aren't there any longer. However, having all the data and the tools, or at least many of them, in the cloud, as long as you've got a halfway decent internet connection, which I realize is not ubiquitous around the world, and we still have a ways to go, but being able to do this, being able to pull up, okay, I've got ArcGIS online, and I've within a few minutes I pulled together. Okay, I've got some recent tropical depressions and tropical storms. I've got the current weather happening right now, where some of you are located. Looks like a pleasant day, etc. Evening. So I've got some real-time data feeds coming into this platform. I can add data if I want to from, for example, the Living Atlas of the World has 8,500 layers just in that one data portal alone. Now, sure, we want to have students and faculty understand where the data came from, who created it, how often was it updated or curated, the scale it was created at, and so on. So that's of very much concern to me. And so if you're at a computer, which I realize all of you are right now, if you could do a search on spatial reserves and go to my spatial reserves data blog, this is a book that I and a colleague wrote. And every week we update the data blog about where to find data, spatial data, how do we know if it's any good, can we trust it, and societal issues like location privacy, whether data should be charged for and licensed or should be just openly available, all of those sorts of societal issues. So it's called the Spatial Reserves Data Blog. I know it sounds really boring, right, having a data blog, but I just submit that this is very important to our discussion because we have these tools where we can easily pull together data sets like this. Well, again, where did that data come from and can I trust it? This is a completely open platform. So anybody is a data producer nowadays. Anybody can put data up here in this environment. And so you as the data consumer then have to be critical of the data, okay? Now, back on our 5 forces, citizen science, I submit to you, is another key force in our time. Citizen science goes way back to the 19th century or even earlier, right, with the birding community. Oh, the size of the bird, the call of the bird, the feathers on the bird, what it sounds like, the species of the tree that it's in, the species of the bird itself, etc. So citizen science has been with us, but people were recording that on paper, right? And more recently, it's been receiving a huge boost because we can map the data now, as I showed in my walkability survey, right? That's citizen science. Is your community walkable by pedestrians or not? And how so? That's citizen science, and I can map it and then I can analyze it. The reason why I say I can analyze it is because oftentimes I get emails and phone calls from people. Hey, Joseph, I've mapped my data. Great, I'll say, and, right? And I want people to move beyond the mapping part. They're understandably excited about geotechnologies, as I know all of you are, but as my previous colleagues have, I think, very well pointed out in their wonderful presentations, it's all about the analysis. What can we learn from mapping and analysis, right? We want to understand something in a deeper, richer way, whether it's biodiversity loss or water quality or natural hazards or whatever the issue is, right? It's not enough just to map things. You've got to analyze it and then understand it. I think about that whole geographic inquiry model where you're gathering data and you're analyzing it, and then you're acting on it and making decisions, and that leads to additional questions. So I always say move beyond the mapping. Storytelling with maps has received a huge boost. Now, one might argue, rightly so, that maps have been used to tell stories for thousands of years, right? On clay tablets, metal, right? Al-Idrisi's silver map from the 1100s, wood blocks etched in dirt, more recently on film, and then also on, in more recent times, in digital form. So maps have always been used to tell stories, but the Story Maps platform, for example, this whole thing, if you look in the URL in the upper left, is a story map. This whole presentation that I'm giving is a story map. So sure, I still use Prezi and PowerPoint and Sway, but I also use story maps to present with. And I'm going to give you the URL of this story map at the end of the session that I'm in here, which I have about 10 more minutes. But the point is, stories have been receiving a huge boost through Story Maps platform. So I realize there are several kinds of ways to make multimedia story maps, but the Esri Story Maps platform alone, as of May 2020, there were 1.25 million story maps, just story maps, here, of a wide variety of quality, but story maps have received a big boost through these. Now, again, I'm very excited that GIS has become this platform technology that people can build on. That's what platform means, right? People can build on it. No longer is geospatial technology some sort of niche thing, again, down the hall and to the right in a typical city government or in a university. It is becoming a platform that people can build on. And I would also argue that despite all of the major IT changes over the past 50 years, GIS has not only survived through all of those changes, but it has actually thrived through all of those changes, okay? And the cloud is important for several reasons. One, all of these issues that you and I care about, water, environment, et cetera, they don't stop at disciplinary boundaries, right? We need the economists, we need the historians, we need the data scientists, we need the geographers, we need the climate scientists, et cetera, right? They're interdisciplinary, these problems. And so having it in the cloud allows us to collaborate, just like, you know, you putting your Google Doc in the cloud allows you to collaborate with a colleague on writing a chapter for a book or a paper or something, right? This is even more important because it allows us to not just share the methodologies, but the data and the workflows and the results through story maps and other tools. So that collaborative environment is important. Also, these issues don't stop at political boundaries either, right? They don't stop at regional, city, national, international. They're global in nature, and they increasingly affect our everyday lives, as my colleagues before me have talked about, this very serious water issues that we're facing in this century. And lastly, they don't stop at physical boundaries either. They don't stop at one ecoregion or one watershed or one river system, right? They transcend all of those boundaries. So it's very important that we have this cloud-based platform to collaborate with geospatial technology on. Now, one of the things that's really exciting to me is the 5 trends, and I'm going to skip to the 5 trends here. Again, just like the 5 forces, these are, you know, like any list that you see in an article or on the web these days, they can be argued. And you may say, hey, Joseph, you're forgetting this one, or I don't agree with your 5. And I'd love to have a dialogue with you about that. But these are just 5 that I believe are important in, you know, a whole lifetime here of working with geospatial technologies. This is my homeland, by the way, Colorado, Western Colorado, very dry, arid environment where I'm speaking to you right now. And so we're all tied to space and place. That's why I thought I'd mention it. But this ridge behind me was on fire for all of August. Now, fortunately, nobody lives up there, There were some wild horses and some sagebrush and some low trees here. But the point is, these issues are affecting our everyday lives. 3D, we've had 3D visualization for quite a few years now, correct? But now we have 3D analytics, which I think is important because we have a 3D world and we need 3D analytics tools. Building information management, computer-aided design or drafting, and the architecture, engineering, and construction, not merging, but at least touching on the GIS community. That's important. So we're starting to see tools, for example, ArcGIS Urban and others that allow us, ArcGIS Indoors, that allow us to model interior spaces and exterior spaces in the same environment, which is important because let's say your typical university campus, there's some sort of weather event that happens at 1400 hours on a Friday. Where are the students? Where are the faculty? Where are the emergency exits? If we had our interior 3D models merged with the campus map, that could be very powerful. It could potentially save lives. So it's important that we have this dialogue between those communities that were in prior years pretty much separate, the interior space mapping people and the exterior space mapping people. Real-time data and analytics. I had that map in ArcGIS Online where you saw the real-time data feeds coming in, stream gauging stations, traffic, weather, etc. Having that GIS connected to this Internet of Things where things are increasingly tied to location is hugely important. GIS is becoming the sort of nervous system of the planet, right? Just like your body has a nervous system, GIS is helping us monitor the planet as never before. And without your nervous system in your body, none of us would be here. And just like GIS empowering the lights, the food you ate yesterday, etc., the assembly of your phone or your computer, supply chain management, and GIS is behind all of those things. It's sort of like an elevator. You get into an elevator and you push buttons and expect it to work, right? That's how GIS is operating behind the scenes. A lot of people don't realize that. But the fourth trend that I would like to submit to you all to think about today is enterprise and web GIS. I talked about this earlier with GIS in the cloud and being a sort of valued asset in an organization is a huge leap forward. And finally, artificial intelligence and machine learning. This cannot be overstated. It is rapidly transforming our world and geospatial technologies. Having tools like this, where you've got just on an app on your smartphone, being able to determine with a feature service what's underground, it could save a municipality, for example, lots of fuel, money, time, having to, oh, we don't know where this water main is. We have to dig up the road to figure it out. Well, what if that was in your geodatabase and you've got this app on the surface and you're gathering that data? Similarly, on a typical university campus, for example, if every single thing here, every tree species, every sidewalk, every sign, every condition of the road could be automatically gathered through these AI machine learning algorithms, we could be gathering all of that data pretty much instantaneously once that video gets uploaded into our system, and therefore the whole workflow of having to manually input every fire hydrant and light pole and tree, etc., is going to be over, which is going to transform a lot of those entry-level GIS jobs into something I think more exciting because they'll be able to skip more to the analytical stage. All right, in my final minutes here, I want you to think about this. We have serious issues on our planet: environment, accident data, etc. In the first years of GIS, we were using GIS to replicate what we were doing with manual cartography. And that was okay because now we could make maps of rivers and roads and biomes and ecoregions, etc. But now we've moved into another phase where we're looking at things in different ways that we could never do with paper maps. So for example, in the early days of GIS, we would do this kind of thing. We'd map whatever variable you're interested in, water quality, pH, dissolved oxygen, or in this case, accident data, traffic accident data in a community. But now what we can do with geospatial technology, right? We can create hex bins out of that data. And we can say, okay, well, now we want to look at statistically significant hotspots. Every project has a finite amount of hours, staff, budget, right? So if we can focus in this case on consecutive hotspots where there's accidents and focus on those, we could, again, make our communities safer because of the new way of analyzing data through GIS. We're not just replicating what we used to do with paper and film. We're in this next phase where we can do things in new ways. That's pretty exciting to me. All right, in my final minutes, I'd like to skip to this. And this story map that I'm showing you right now, folks, if you go into it, I've got some things that I skipped over because I wanted you to have more information. I have reports from the World Economic Forum about the trends in workplace, workplace and employment, and how GIS is changing and what you can do to foster geoliteracy on your school campus or on your university campus, or work with university faculty or school teachers that you know. But here's what I submit to you as the top 5 skills for geotechnology professionals and instructors and students, and I would submit others. But be curious. That's the most important skill, because it's great to know how to buffer and overlay and geocode, but this is the most important tool of all, right? Your brain. This is the most important spatial thinking tool that you've got at your fingertips. So be curious. That leads to tenacity. You're asking good questions. Ask questions that your university professors aren't asking, you students out there. You people in the workplace, ask questions that your employer is not even asking you. That's the kind of people that we want at our organization and that other organizations want. Second, be willing to and able to work with data and be critical of it. Remember my spatial reserves data blog. That is all about being critical of data. That is so important in our world, especially because maps tend to be believed. Maps tend to be believed. And so it is important to be critical of all data, including, and I would argue, especially mapped data. They're very useful, right? But be critical of them. And so also, on a related note, understand the ethical implications of what you're doing. We all have a powerful set of tools at our fingertips with geospatial technology, don't we? Use them wisely and be careful about what you're doing. Okay. In my last minute here, I have a third component here. Know your geospatial and geotechnical foundations. Know about how these web maps work, how they're put together. Know a little bit about geocoding, or about Python, JavaScript, etc. Projections, analysis, classification, and the content knowledge as well. So for example, if you're in hydrology or if you're in human health, the content knowledge is important. You're using geospatial technologies as a set of tools on your tool belt for your main content knowledge. And then adaptability. Be willing to go international. We've got a whole international group of people here on the conference here, or at the very least, go outside your disciplinary comfort zone. So in a conference like this, go to something that is completely outside of your own, wheelhouse, or something that you're not really familiar with. It'll extend your knowledge. You'll meet some new people, and it'll be interesting for you and help you grow. And then good communications. Do you have an elevator speech when your city manager, your CEO, or your university president comes down the hall and says, hey, we need to justify your position and you need to give your 1-minute speech or your 30-second speech or your 5-minute speech? Do you have that speech done and being ready to communicate it? Because despite the geo-awareness that I was talking about earlier, there's still a lack of awareness around the world in why what you and I do with geospatial technologies matters in the general scheme of things. So be prepared to have good communication. In sum, I believe this decade is going to be exciting for geotechnologies. We've got some serious issues, as we're all talking about in this conference, but we've got good people like you all. We've got some good data at our fingertips. We have some really good tools. We have a network. We're collaborating, and we're going to solve these problems. I'm an optimist. We're going to grapple with these problems and solve them. And so the goal, right, is that wise decisions will be made with the spatial perspective and the use of geotechnologies to build a healthier, happier, and more sustainable future. All right, questions, comments, issues?
Very nice. Thanks, Dr. Kerski, for a very nice presentation. I hope we have a lot of curious participants here.
Dhanyawad.
Swagat aapka. So, Dr. Shalini, do we have some very curious questions from our participants? You are muted, Dr. Shalini.
Madam, आपका mic on कर.
most of the participants have appreciated the presentation of Professor Joseph, and they would like his email for the personal interaction. And one of the participants has raised a question that can we use remote sensing data in earthquakes and cyclone storm?
Well, absolutely. You've got at your fingertips a variety of remotely sensed data. You've got the Sentinel-2 imagery. You've got the this kind of thing, the Wayback imagery. I don't know if you've seen this, but this is a tool where you can. I'm looking at Bhopal right now, and I've got 2020 on the left side, 2014 on the right side. So I've got I can see some land cover changes, some building construction. And this is a tool that you've got at your fingertips in terms of imagery. You've also got this thing called the Water Balance app. Again, this is part of the Living Atlas that I referred to earlier. You can see right by where many of you live. You can see the soil moisture changing. You can see the precipitation. You've got the wet season and the dry season. It's just these tools are just wonderful, and they are increasingly on the web. And these tools that I've just mentioned here, no login required, no sign in required. So yes, absolutely.
Okay,
तो धन्यवाद डॉक्टर जोसेफ.
I'm also going to put one more resource in here. I don't want to intrude on the next speaker, so I'm going to say again, Dhanyawad. Thank you very much, and I wish you all the best success. Let's keep in touch, and I'll put my contact information in here.
Thank you again, and very nice to listen to some of these wonderful ideas. With that, we move to the last presentation of this session. And we already see the screen of Dr. Ashish Pandey, who will be talking about application of remote sensing in GIS in soil erosion modeling. Soil erosion is a very important topic for water resources professionals, for agriculturists, and for a host of people in different disciplines. So I now request and invite Dr. Pandey for his talk.
Thank you, Professor Jain. As my topic is application of remote sensing and GIS in soil erosion modeling, so I would like to tell you in brief about importance of soil erosion. Because we all know that reservoir and river sedimentation is one of the challenging problems in the water resource sector. And due to this climate change and land use changes, there has been significant increase in the soil erosion. Further, removal of topsoil from the catchment also reduces the crop productivity and deteriorate the water quality. Therefore, identification of vulnerable soil erosion prone areas in the catchment is a prerequisite for providing proper soil and water conservation measures for food security and sustainability. In this regard, this modeling can be an important tool for planning, development, and management of water resources in time and space, considering various scenarios. My previous speakers have already told about what is remote sensing and what is GIS. But in short, I would like to tell you that when time, money, and spatial information is a constraint, under these circumstances, remote sensing can play a vital role. In India, there is one proverb in Hindi, "Jahan na jaye Ravi, wahan jaye Kavi." In the similar fashion, this remote sensing can go everywhere, right? So from this remote sensing, you can gather all sorts of information which are required for natural resource management. Remote sensing was started in India in, say, 1971. At that time, nobody realized that our population will be around 1.35 billion. But they thought that why not we should do some planning for future. At the time of Green Revolution, population of India was around 30 or 40 crores. then at the time of Green Revolution, our production was also less. But now if we see our population is around 1.35 billion and our production is 285 million tons. It is expected to that population will be around 1.6 billion in 2050, and at that time the food grain requirement will be around 375 million ton. And at the time of Green Revolution, our crop production was 1.7 tons per hectare, which was lowest in the world. But now our production has increased. It is around 3.7 tons per hectare per year. So looking to those things, this concept of national natural resource management started, and remote sensing and application of remote sensing was welcomed at all the sector. If we see the fields where we can apply this satellite data and the GIS, GIS and remote sensing are both, if both the things can be integrated, are both the information from remote sensing and capability of GIS are integrated, then they can do wonder really. You can see that number of fields where these GIS can be applied. But one thing is very important, whenever you are talking about use of GIS, one should have very good quality data, good quality hardware, good quality software, and a skilled personnel for managing and analyzing the geographical data. There was a report in Cornell Chronicle in 2014. USA is losing soil 10 times faster, and China and India are losing soil 30 to 40 times faster than the natural replenishment rate. If we see the cost wise, USA is costing around 37.6 billion per year. India is costing 46.9 billion per year of productivity. And if we see in the worldwide, we are losing around 400 billion per year. Again, there was a statement by our honorable minister at that time. India is losing soil around 5,000 million tons of soil annually due to soil erosion. How does this soil erosion impact us? Because we have seen that, we know that how water is important for us. But many of us are really ignorant of this soil erosion or soil loss. It takes around 500 to 1,000 years to develop a 1 inch of soil. And due to this soil erosion, we are also losing the most productive soil with organic matter and nutrient. And the sediment which we are losing, it is going to reservoir and rivers, and ultimately their capacity is reduced and creating a serious problem of flood and pollutants in the downstream area. So this is really very challenging problem. If we consider the geological erosion, it's around 0.2 to 0.5 tons per hectare per year. In India, the national average is 16.35 tons per hectare per year. If we see the overall situation in India, around 57% of the soil is potentially exposed to degradation, and in which mostly 45% area of that 327 million hectare is suffered due to water erosion, followed by this wind erosion, chemical degradation, and physical degradation. If anything is more than 5 tons per hectare, that is really a serious. And here in India, we are having soil loss of say 16.35 tons per hectare per year. And for any natural resource management phenomena, or even for soil erosion, the factors which really affects our climate, vegetation, soil type, topography, cultural practices. Since my presentation is basically based on how we can use remote sensing and GIS for identification of critical erosion prone area in the watershed, for identification of suitable sites for soil conservation measures. So in this regard, a study area that is known as Kerski watershed, it is situated in Hazaribagh district, was selected. These are the salient features of the study area. The data which we have used is obvious: meteorological data, hydrological data, daily runoff and sediment yield, survey of India topo sheet, soil texture from the Damodar Valley Corporation, and cloud-free data of IRS 1C, list 3. And these are the maps which we generated, because the beauty of GIS is that you can create number of layers, and those layers are going to help you when you are going to make some decisions. Hydrological data processing, scanning of topographic maps, rectification, delineation of watershed boundary and sub-watershed boundary, establishment of digital contour and drainage network, establishment of soil coverage, land use and cover classification, so on and so forth. Many newcomers may be surprised that how I am talking about scanning of topographic map, because now there is a trend of having DEM from ESTA data or SRTM data, right? But when this study was carried out, at that time this SRTM and ESTA data was not available. At that time in India we are having topo sheets. So with the help of topo sheets, digital elevation models were developed by digitizing the contours. Then from this contour map, the slope map was established, and these are the slope categories identified. Then how the soil loss was calculated. Although there are so many models like SWAT model is there, web model is there, ANSWER model is there, through which one can estimate sedimenting. But you know that this universal soil equation is a basic equation and most simplest one, because it requires only 6 parameters like rainfall erosivity, soil erodibility factor, length factor, slope stiffness factor, conservation practice factor, and crop management factor. So here I can say that the factor, especially C and P, these factors can be obtained from the remote sensing data. These LS factor was obtained from that DEM generated from the contour map. But if we see the present day situation, and so we can use the ESTER or SRTM data for generation of this slope length factor. And the soil erodibility factor, definitely in this particular study, this soil erodibility factor was estimated using some field observation and later on using some standard equation. And rainfall erodibility factor was estimated from this equation given by Wishmar and Smith. Now, even for rainfall erodibility factor, one can use satellite data like TRMM data and GPM data products are available through which you can estimate the rainfall erodibility factor. To estimate the soil erodibility factor, this particular equation was used, and this is the soil spatial distribution of soil erodibility factor. Then this slope stiffness factor and slope length factor was estimated by these two equations. Here, if slope is less than 9% and for slope length more than 4%, these equations were used. Although so many equations are there in the for estimation of LS factor in the research paper, but after doing lot of permutation combination, I found that this kind of this equation is going to help, and this will be applicable in the study area. Here the grid size was 200 millimeter. It means that the soil loss which we calculated, it was for around 4 hectare area per grid. Then since land use level, land cover is one of the most important thing which is required to know the crop management factor and conservation practice factor. So first color composite of that particular watershed was collected from the NRSC, and land use land cover classification was carried out in different classes. Agriculture was the highest land use land cover class in the state area, followed by degraded forest and wasteland, so on and so forth. And the accuracy assessment was also carried out for this particular land use land cover classification, and it was found that overall accuracy was around 88% and kappa coefficient was 0.86%. And we know that in remote sensing, whenever we are doing classification, if your accuracy and this kappa coefficient is more than 0.75, then we consider it as at acceptable level. So we accepted that our classification is good. Then with the help of this satellite data classification, this crop management factor and conservation practice were decided. So we selected this conservation practice factor based on some studies carried by the scientists of USDA and Rao. And since in this particular area there were no soil conservation work were carried out, so in the area where paddy cultivation was there, P was adopted as 0.28, and in rest of the area, conservation practice was adopted as 1. Finally, because we know that whenever we are doing modeling, if you are not comparing the modeling result with the observed data, it means that your modeling results are not at all acceptable. So to validate the data, we compared the observed sediment till with the estimated one, and you can see that the percentage deviation of the observed sediment from the predicted varies from 1.3% to 13%, so it is at acceptable level. Then finally, after doing this, when we were confirmed that now our results are satisfactory and we can accept it for further processing, so the whole this soil erosion or sediment till was divided into 6 scales of priority, like 0 to 5, 5 to 10, 10 to 20, 20 to 40, 40 to 80, and more than 80. Because we know that whenever we are doing some soil conservation work, it is not at all possible to do the conservation work in whole area. So we have to start it from the critical prone area. So we did the same thing. We find out that which one is the most severe area, followed by severe, very high. So here you can see that these are the places where soil erosion is more than 80 tons per hectare per year. So one can start conservation works from these particular places so that soil erosion can be minimized. Further, these area under different soil erosion classes were also divided, and you can see that since if you can recall the LS vector map, that in most of the area our slope is 0 to 3%. So it in the similar fashion, it is showing that 82%, more than 82% area is having slight soil erosion class, followed by moderate, high, very high, severe, and very severe. But you know that since if your soil loss is more than 5 tons per hectare per year, so one has to go for some conservation measures in the watershed. But what we thought that in the places where soil loss is more than 4 tons per hectare per year, so in those places also we have to put some emphasis, or we have to put some conservation measures so that in future it is not going beyond 5 tons per hectare per year. So what we did, again, we divided the watershed into sub-watershed, and since it was done in the GIS environment, so it was really very easy to do the estimation of soil loss on sub-watershed basis. And we found that in the sub-watershed 4, 3, and 1, the soil loss is more than 5 tons per hectare per year. So it gives us idea that we should go for the sub-watershed where our soil loss is more than 5 tons per year. Then only having a problem or just identifying problem is not sufficient. So what we did, we developed a conceptual framework considering field data, satellite data, and survey of India topo sheet to find out the suitable sites where we can have some soil conservation work and water conservation work also. So, and especially whenever we decided some structure at a place, so we kept a buffer of 500 meters for village, so that whatsoever we are going to create some water body, it is really helpful for the nearby community. So we did that, and we selected some suitable sites for location of this percolation tank, check dam, nala bund, and there were some structures which were already there. And finally, this is the procedure how we did it. Initially, a drainage layer was overlaid on slope, soil, and land use map. Then drainage pattern, slope, soil, and land use map of the watershed was carefully studied, and structures were decided. And since we had some background, or we had some information that which area should get top priority, so we selected those sub-watershed where soil loss was more than 5 tons per hectare per year. And this is the final conclusion, that we could estimate sediment yield in accurate manner. And we also find out the sub-watershed where soil loss is more than the acceptable limit. We developed a conceptual framework for designing of soil water conservation measures and their site suitability mapping. So at the end, I can say that this high quality output and easy updating capability of GIS is really helpful for decision makers. And this GIS and remote sensing can help a lot in development and management plan for policymaker to handle soil erosion problem in holistic manner. Thank you. If you have some question, I would.
Yeah, thank you, Pandey, for a very useful and nice presentation, highlighting how remote sensing and GIS tools can be applied to solve the practical problems. Now, are there some questions?
Yes, sir. One of the participants has inquired that whether increase in the water table may cause the soil erosion or not.
I think there is no relation between water table and soil erosion. If water table is high, then there is going to be a waterlogging problem. That much I know.
Another interesting question is, does soil erosion causes the forest fire?
Soil erosion, forest fire. I am not sure.
I don't think there is any correlation between the two.
I don't think so. There is any correlation. It was just what one of the participants has asked this question.
I have one question, Professor Pandey.
Yes, sir.
You know, with this now wider availability of remote sensing data and good quality data, how much is the improvement in our soil loss assessment by using these data over the collection methods?
Sir, really now we are having this synoptic data of this land use, land cover, so our soil erosion quality, estimation of soil erosion has improved a lot. Because in this particular study, you can see that the variation of percentage deviation of sediment was only from 1.4% to 14%. So this is really very encouraging. Whenever we are using these visually based model like SWAT, WEP, ANSWER, so their data requirement is so high. For example, the data requirement for WEP model is 1167. So really it's very difficult in real practical application for estimation of soil loss. So under these circumstances, I think one can use this USLE model, which is having only 6 parameters, and he can do a lot of permutation combination work, and he can calibrate that model for particular area, and definitely the results are going to be very well. And since you are getting the land use, land cover free of cost in dynamic manner, so you can update your results also. So in this way, it is going to help a lot.
Thank you.
Thank you, sir.
Are there any more questions, Dr. Shalini?
No, sir. There are questions, but those we can answer later on via emails.
Okay. Well then, I think we are coming to the close of the session. And to me, this was a very interesting session. In short, 4 presentations. We covered a lot of ground. We started from broad description of geoinformatics and the exciting developments in this field. There was a talk on application of remote sensing GIS in water resources. Then Dr. Kerski took us to the future and told us some really very exciting developments that are taking place in this field. And you know how some of these things are being used to answer the questions which we were all wondering earlier, but now we have real data to answer the question. And finally, we had a very practical application of remote sensing and GIS tools for water resources problems. So I would like to congratulate all the speakers. I would like to congratulate the organizers for giving me this opportunity. And I would also like to thank all the participants, delegates, who asked some very interesting questions and who are present in very large number. So thank you very much. And now back to the organizers.
Thank you, sir. I would like to thank all the potential speakers and our participants for attending the session, and the speakers for delivering such informative lectures. Once again, thank you, and special thanks to Professor Joseph for attending the Indian conference and being a part of India. Now I would like to hand over to Dr. Yadav, sir.
Well, I don't know how to express my feeling, but definitely I'm grateful to Dr. Saraj Jain, who accepted my request to chair this session. And I'm also grateful to Professor P.K. Joshi, Dr. Chander Kumar Singh, Dr. Joseph, and Dr. Ashish Pandey, accepting my request to be a keynote speaker and delivering their lectures in this important conference and sharing their experiences. So once again, I thank you to all, and I am also thankful to all the participants who have spared their valuable time and has shown very keen interest continuously listening to all the speakers very sincerely. Now I request all of you to join tomorrow sharp at 5:30, that is the 17 hours 30 minutes. Tomorrow, that is the IST time. So our program will start tomorrow at 17 hours 30 minutes sharp, and it will continue up to 21 hours in the night. So thank you once again. Thank you so much.
Thank you. And thank you very much, sir.
Thank you to all. Thank you.
Dhanyavad, Dr. Kerski.
Dr. Daniel is also on the line.
Call.
Dr. Daniel, you can unmute and.
Oh, Dr. Daniel. Dr. Daniel, really, I'm very happy to see you.
And
hope to see you tomorrow also.
Hello, hello. Thank you very much for very interesting workshop. And I'm happy to see you again. And
thank you, Professor, for attending the workshop. We
please?
hope to see you tomorrow again.
Yes, yes, of course. Of course. Thank you. Bye-bye.
Bye-bye.
Good night, sir.
Good night, sir. So, Ravisha, shall we leave now?
Yeah, we can leave. Thank you very much.
Thank you, sir. Thank you so much.
Thank you very much. We'll see you tomorrow. Indian Standard Time, 7:30. Okay. We can log in at 17
Yes,
hours.
5 or 5:15.
Okay.
Okay, sir. Okay.
Lectures will start from 17:30 Indian Standard Time. Thank you very much to everyone.
Thank you, Sukant, for managing very efficiently.
Thank you, madam.
Thank you.
Okay.